Hi, Stafford. Good evening.
Good evening, ma'am. Are you able to hear me?
Yeah,
Perfect.
you can hear it. Manju Prasad, sir?
Yes, ma'am. Can we start, ma'am?
Yes, sir, we can start.
Good evening, one and all present here. All the participants, still few more participants need to join. So in meantime, we'll have the introduction of today's resource person. It's now my privilege to introduce the today's resource person, Mr. Stafford Michahial. So he's a seasoned technology innovator with strong expertise in robotics, AML, neuroscience, motion capture, simulation, and product engineer. He currently serves as a chief technology officer at Neuroscience Innovative Solution Private Limited, and also as the CTO at PRS Neurosciences and Mechatronics Research Institute, where he works on a cutting-edge solution in neurorehabilitation, robotics, and human motion analysis. He brings with him rich industry experience across a hardware and software development, XR technologies, robotic simulation, and applied research. He also held leadership role in product development and innovation, and has academic experience as a assistant professor, which add a great value to his teaching and mentorship approaches. So, and one more thing, unfortunately, no casualties happened. So today, our resource person, Stafford Michahial, was out of station and he has met with an accident. So, but no casualty reported. And despite of this incident, Stafford has committed for our FTP, and he made a suitable arrangement out of station, and he made all the arrangement for presenting all the particular session. So it's our privilege to get a resource person like this, and we as an organizer, so we sincerely appreciate the effort and dedication of Mr. Stafford Michahial for making this its dedication and ensure that the FTP is not tampered. So Stafford, thank you for this one. So hope no issue at your side and you are okay to start with the FTP.
Thank you, Manju Prasad. I think today, yeah, I think I had a small incident, but I think I'm okay about it.
Thank you, thank you. So because
Yeah.
instead of that, so yeah, just join the session and you're training all the participants on this one. So I request all the participants to just make use of the expertise of the Stafford Michahial and get benefit from his session. So I will now hand over the session to Stafford Michahial. So Stafford, so can continue. Are you able to share the screen, Stafford?
I am trying to share the screen.
I'll just check whether you are. You are now the co-host. You can just share your screen.
Yes. Is my screen visible?
Yes, sir, Stafford. Visible.
Yeah, visible. Perfectly. How can I modify it? Okay, so let me start with the introduction about what I'll be doing today, and let's go from there. Is my slide visible?
Yes, sir. Visible.
Yeah. Okay. So today my topic, I think thank you GSSS for inviting me for giving a talk on what I do, and what I am very much happy across to sharing across is what I do in robotics. So it started along in GSSS itself for me as an assistant professor. I started there along with Dr. Shiv Kumar, who is the current principal of GSSS. Worked under him in order to understand robotics in my early stages when I just got graduated from GSSS from MTech and joined there as an assistant professor. I think Manju was also one of my co people who were working in the separate labs. We used to sit opposite to each other in different labs. So from there, the journey started, and I've ended up in last 15 to 12 to 15 years worked on extensively on robotics in various industries such as Indian Army, GE, or it might be ISRO. So right now I'm in Tirupati. I was traveling from ISRO to Bangalore and met with an accident in Tirupati. So I'm staying in Tirupati just to finish certain formalities of what happened. So I couldn't get into my house in order to sit on my desktop to start off with the resource that I already had. So I pulled out some of the resource, but still I was not able to complete. So I'll be trying to give you out what I do in ISRO itself. Since that project is there on my laptop, I can just share you some of the glimpse of the software, what I use across, and how do I connect ROS and the other softwares to make a complete package, because we don't want to use any package which is done by any other country. So it's not only for make in India and design in India only for the hardware. It should also be make in India and design in India for the softwares also for these kinds of robots that we are looking into. So the simulation first approach for robotic education and research. So this is the major topic which I have taken across, which I normally use across in my system or in my part of my life, where I simulate things before even entering into the real world, to understand its faults, to understand its capabilities, to understand its pros, to understand its cons. So all the things can be simulated before even touching the robots, because robots are really expensive and dealing along with them is much more difficult. So what is a problem statement which I coined across in this workshop is that robot needs a safe, testable, repeatable planning. So you can try out various kinds of test cases on a simulation than on a real world robot and see how it works across. The real world robots, as I told you, they are very expensive and risky and can cause harm also if it is not controlled properly. And in education, we need to teach, at least if we are not able to invest in giving out robots like KUKA, ABB, or universal robots. So I'll be taking an example of a universal robot of how it can be used, how those simulators can be brought into the ROS and then work along with various other softwares like Python or Unity, or it and control and make a design package for it. So we'll be getting into it. So the first thing that I want to ask the participants, because this is an interactive session and I just have 1.5 hours, so I want to complete my entire system here. So what do you think? How many of you know what is IK and FK? You can just raise your hands if you know, or you can just answer these questions if you think you know these uh, part of it. So raise your hands if you know what it means, or
Sir, I think IK means inverse kinematics
yeah,
and FK means forward kinematics.
yeah. So if you have heard it in your mind, you can say, hi, hi, hi. I have heard this word before and I have used them, but I have never used them. So how many people here have used IK and FK? So if you have used it, you would know how the kinematics work across and it is very important for a robot or a robotic arm or a humanoid robots to work across, which is the current trends that is running in the last few years, that because of automation. So, and if you don't know also, and if you have a new clue also, it is fine, because we will be going into a stage of learning. That is where if you are in a stage where you say, I don't know who is IK and what is FK, it doesn't matter. We will learn about it. If you know it and if you have heard it, but you don't know how does it work, but still we are going to learn about it, how it's going to work. At the end of this workshop, all I want the participants to know is that they want to be in a place where they know what is IK and what is FK and apply them in the real world robots to say, how can I apply forward kinematics and inverse kinematics into the system? Because this is a basic step for the path planning for robotic arms. So why this matters? So the important step of this is that every skill in our journey follows this ladder. That is, the inverse kinematics, forward kinematics are like learning to walk and balance in robotics. So our whole goal is to make it move from I don't know to I know, which I actually explained what is it in the previous slide. So now the FK robotic control work in this workshop, basically I'll be giving out with this what is the forward kinematics and how is the inverse kinematics. And you can see in this example, like I am just controlling a target and the robot arm is able to move across and understanding how to move in the direction. So this is where you need to know how the FK would work and how the IK would work. And using this concept and IK principle and the ROS simulation, how do we build such kind of robotics for ourselves? Because most of the libraries that we use across is built by somebody else. Like for example, a turtle bot, or it might be a Firebird, or any kind of a robot that we use across. They have created their own hardware. They have created their own path planning systems on top of it. When we create some robots similar to of those kinds of features, we also need to put out these libraries out so that the people can use them, and also give them simulations so that students or the researchers can not worry of purchasing a robot, but instead directly use the robot when it is handed over to them. So first we will learn how to connect the UR10E, and then using the commands, send these commands to the ROS and get back the output across. So let's see how do we do that. So the core concepts of what is IK and FK. So FK is the forward kinematics, in which the end effector post used to visualize and simulate robot motion. That is, for example, in forward kinematics. So let us do a small example of it later while I'm giving this system. Now, next is to understand what is inverse kinematics. So the end position is required. Automatically, the joint angles are calculated in order to reach the end position. That is what is called inverse kinematics. So both forward kinematics and inward kinematics has to be used. In case of humans, we are balancing on our own by using the forward kinematics. But if I ask you to pick up a bottle, that is when the inverse kinematics comes into play. So both forward kinematics and inverse kinematics has to work together hand in hand in the applications where it is suitable for. So you should know where, in which application I should be able to apply forward kinematics, in which application I should be able to apply inverse kinematics. So let's understand what is kinematics. So kinematics is a study of motion, how things move without worrying about the forces that make them to move. So, and also this is a general definition of what is kinematics. And in robotics, we control joint angles. We also understand the link lengths, that is the length of the arm, length of the forearm, length of the wrist, length of the end effector, the tool position, where is the tool tip. All of this position matters when we are controlling them. It's like understanding whether your hand will be able to blend when your elbow rotates or your shoulder is moving across. So you can keep your wrist at the same positions while moving your elbow also. So which means that is what is inverse kinematics is all about. So let's go into the definition of forward kinematics and see how we can understand it in a better way. So the forward kinematics tells us where the robot end effector will be if all the joint angles are known. For example, if I am giving an real life example, is like, for example, if your shoulder angle, so for example, if you're moving your shoulder angle by 45 degrees and elbow angle by 90 degrees, it would result in a following action to say hi. So you can move it between 90 and plus 45 on the other side, minus 45 on the other side to make it say high. So this is what is forward kinematics is about. When it comes to the inverse kinematics, how is the forward kinematics calculated? There's a very simple formula which is being displayed on the screen. This is for the two link joints. So if you already know the angles, you can specify the angles for the end effector to reach to that goal using this particular formula. Now, coming to the inverse kinematics is a reverse of the problem. We have to find, we know the end goal, but we don't know the joint angles. So here we are going to compute the joint angles and then reach the end goal, was the inverse kinematics is all about. So when you understand what is forward kinematics, we know the joint angles, we don't know the end effector. But in the inverse kinematics, we know the end effector, we don't know the joint angles. So that is what is the system here. So now, for example, if you place your phone on the table and I ask you to, that is the end position now. The phone is the position in a 3D space. Now I ask you to reach out through it, which means your hand automatically understands what is the best position to reach based on the collision avoidance, everything, and pick up that phone for yourself. So that is what is inverse kinematics is all about. So any questions do you have about forward kinematics and inverse kinematics? Because we will be moving into the next topics after this.
No, sir.
As everybody understood, I would say that you have moved from I don't know to I know of what is inverse kinematics and forward kinematics is what I assume. So the mathematical part of it is as described in this formula. So this is the inverse kinematics formula. I know it is complex, but since there is ChatGPT and all the other formats present right now in the AI, this can be done in a faster way. And you can provide the 3D space XYZ coordinates to this, and you can generate a desired position. Now, what I'm showing here is a SCARA system robot, which can write on a board. So with this formula, you can have a two-link joint, which you can make them use to write an A, B, C, D, and so on. As the number of link increases, the complexity of generating the angles also increases. So there are various kinds of forward kinematics and inverse kinematics that we'll be using across in the future. So one such inverse kinematic system that I will be using is called cyclic coordinate system, CCDIK. So that is one of the expressions or the formula that I'll be using in order to calculate the IK positions. So this is just a two-link IK. The next one with what we'll be going into is the circular IK. So this is how the formula is all about and how we are going to represent these values and how are we going to result in what angle it's going to calculate in order to reach the desired position of 5.1 in X and 5.4 in Y. So when we compare forward kinematics and inverse kinematics, it's basically in forward kinematics, the input is the joint angles, the output is the end effector force. The complexity is quite simple because you have already calculated the forward kinematics. Solution is simple, usage is animations and simulations. But whereas when you come to inverse kinematics, but we have the target positions, the output is the joint angles. It is complex because it's a nonlinear equation. Solution becomes more and more complex as number of links becomes higher, but very important in control tracking and targeting and path planning. So that is where the IK and FK comes into play. So now most of the people would have already moved down into a zone to say, I know and I know what it means, but only thing is I need to implement it in order to understand the full usage of it. So what is the workshop promises about is to understand the IK and FK in a simple language, visualize how robot calculate motion, and we are going to try out a simple demo and with a real robot simulation using the ROS. So let's move it to understand how are we going to do the part of it. In the rebooting the brain concept, so normally I run one more podcast, which is called the Rebooting the Brain, which is also present in the YouTube, where we talk about various parts of technology and how clinicals are being used across and how we are helping people who are in disabled and neurological problems, basically held with head injury and spine injury. So everyone expects every expert once said that I don't know, I don't know. The difference is, the key is that they kept learning until they said I know, I know. So that is a kind of concept that even embedded into everyone in the PRS as well as in Neurokaya, so that they keep learning and learning, and they always say that I don't know instead of saying I know, I know. We need to keep learning. And this only happens with this learning loop, which is being represented in the system. So let's begin and start moving it from I know to I don't know. So let me change my PPT. So I'll be demonstrating one of the workflow that I have been developing from past 1 year for ISRO in Sriharikota. So this is an workflow for automated path planning on a 3D blade surface, which is being developed by me. So it's a complete digital twin concept, which we have developed for ISRO mixer. So the problem statement was that whenever the ISRO uses a particular mixture of fuel, which is solid propellant, which is not liquid like how we use in SpaceX or in NASA. So we have a particular patent on our fueling systems, which we have not yet moved on further for going in, because it is cheaper and less cost effective for us, but environmentally harsh. Now, the reason why it is important is that the trust they provide. You might have seen the Bluebird launch that happened. There is a huge amount of smoke coming out of the rocket every time an ISRO launches this. There's also launch in the January 12th. I think that is also one of the systems where one of my systems also will be introduced in the PSLV that we are launching on Jan 12th. So here, what we are trying to solve is that there is a mixer which is about 2.5 ton, 8 feet long and 25 feet height. Now this mixer goes into the robotic fuel, which it keeps mixing at a RPM of 1 RPM. At 1 RPM at a very low speed, because it is composed of explosive materials, and it is oxidized because in space there's completely no oxygen, so it has to be oxidized. So it will be completely oxidized and no friction, no spark, nothing could be ignited on this. Even a friction that touches from a human to human can also lead to a blast in this kind of a scenarios. So they wanted a complete automated system which can work, where we can mix the number of fuels and chemicals into it and clean also. The important part was not to mix it, but after the mixing is done, who is going to clean the blade now? Because that blade is being the blade is being covered with all of these materials, and it needs to be cleaned by a human. So from past 15 years, there used to be humans used to go and clean with huge amount of PPE being wore across by them, going and cleaning with a non-static or a non-sparkable metal, which is a cobalt and barium and some other kind of materials mixed along and made across. So again, this is one of the non-sparking invention done by the ISRO itself. So which does not create a spark even if we rub it on any of the surface, and no friction also. So it's basically a component of multiple polymers and materials fused together in order to make this system. So while creating this system, we had a problem to say, how are we going to clean it? So we came up with a concept called a digital twin, because we created this system. So important in ROS or any of the system that we are creating, the digital twin is very important, because the simulation environment is what needs to be accurate and 1:1. So I believe that in the previous workshops or the faculty development that you have gone through in the in your previous sessions, you would have understood what is ROS, installed ROS, and worked along with URDF files, brought along some table, brought along some other kinds of words into the environment, and used some kind of robot like turtle bot or any other kind of bots, and move in that environment. That is the assumption that I'm coming along with it. In order to go ahead from that part of the work. Everybody agrees up till here? Do you have any questions before I start off with the digital twin development? Okay, so I assume that is to be yes. If there is no, you can always stop me and ask me a question, or you can put it in the chat with whatever question you have, so that later we can have a session where I can answer these questions for you. So the first important system is to understand the environment. So when I saw the environment, there was no CAD models because this mixer was already developed and been presented in 1990s. So now that mixer doesn't have an encoder. Their CAD models are not available. Now this is a very big problem statement for us because we have to create the entire model 1:1 again. So what workflow we followed in order to create this environment is what we call the environment capture. So we call it hollow capture. So in this system, so we have developed this scanning technology where we use lidars and lasers in order to find out the position from a particular surface and start moving it across. So we have an IMU attached to a system. We have the position XYZ, also position sensors attached to the system. We have the laser and the LiDAR to map the surface. So now utilizing the structural parts of it, we create a geometry of it. Next, once the geometry is captured, now this geometry, whatever is captured by the sensors, we call it as a point cloud. That is, point cloud is a several millions of points joined together in order to form a surface. But these point clouds are not arranged to say whether they are flat, they might be distorted. All of this kinds of problems would exist in it. So I'll also be showing you how a point cloud would look like and how do we change it in order to make it better. So now the next part would be to remove all the unwanted points or something which has been cleaning out and stitch all the points together to create a CAD model. So that is the conversion part of it. Now, whatever the system is producing, the LiDAR, or it might be the RGB cameras, it might be the RGB, it might be the IMU sensors that is providing the position, all of them have to be fused using the sensor fusion algorithm, and we create a reconstruction mechanism on top of it. Now, once the reconstruction is done, we run a smoothing algorithm on top of it in order to make a mesh. The mesh is nothing but a 3D solid structure which has smooth surface on top of it. And the normal kind of an export can be multiple formats. The normal format that we use across in all software that is supported is FPX or OBJ or BJB. So these are the three normal formats that is used across. But if you are using NVIDIA, Omniverse and others, you have an USDF file also, which is again a universal screen descriptor. We can use this kinds of models anywhere across because that is a new term that has come across since NVIDIA has come up with greater GPUs. They come up with their own software, NVIDIA Omniverse. So where you can simulate works on GPUs itself instead of CPUs. So which makes the developer's life faster, and also the output is much easier on that when we run it on CUDA and other formats. And physics and animations can also be run. So what is the difference between a CPU and a GPU? So whenever you're running a ROS or whenever you're running a platform like where there is lots of maths computation happening, we would want the CPU to only handle the UI side of it and the GPU to handle the heavy maths part of it. That is like the point cloud, it might be the reconstruction, it might be the arrangements, it might be bringing out the points on the display. So these kinds of rendering and other parts of the stuff should be done by the GPU. And less amount of work should be given for the CPU. And the CPU is only used for threading and multi-channel or multi-threaded programs that we use across. That is the asynchronous or coroutines that we create, where each code is running on its own and using a separate GPU allocated for it. So this is the entire step of the conversion. So let's see what is a digital world actually means and how it actually works. So now this is a mixer. So now, as I told you, with the LiDAR scanning, with the RGB effects and everything generated, we created a 3D mesh structure. Now this mesh structure will be just one system that is present because we are not artists. We're not 3D artists. There is a particular stream of people who do these kinds of jobs. Those are the 3D artist jobs, basically like what you see in the films, like all the film that is being created like Avatar or any other kind of animation films. There is a huge amount of artist requirement who creates 3D models in this format using Blender or Maya or any other kinds of software that is available. Since we are engineers, we want it to be done by ourselves, and a lot of things to be understood with respect to the dimensions and every other thing, we cannot depend on a human, because it will again be a error will be a huge amount of topic in that for us. So what we create is, we use, since the environmental condition is idle and there is no moving parts available, if the entire environment is static, we can generate our own 3D models. So one such example that I have given across here is how I have converted the 3D mesh structure into how I converted the real world into a 3D mesh structure here. So now, once the mesh is created, we are going to low poly. Now you can see in the previous, the lines are all in straight lines. This is how the scanning comes across. Now this is a texture that I have put across on top of it, just a plain white, just to have a basic understanding of how the structure would look like. So it's just a texturing or coloring these meshes. But the output of this cannot be brought into the system because it doesn't have the understanding of what are the moving parts and what are the non-moving parts. So we need to separate them out. So we use, again, we go back to the CAD models where we actually have to cut them, slice them, make them smoothened across. So that is actually a next step where we use where you can see the lines of it. It is all uniform. It's all polygons, squares, which can be used across, so that we can bring out this model in a right way to understand where its XYZ position to be highlighted across. So we cut and chop these models into multiple slices, and each of these slices can be used as a building block for me. So I can select that as a target to say my hand has to pick up this particular block in X as 1, Y as 2, and Z as 5. So I can go and click on that particular box and I can see this is the highlighted block of it. Now, the next part of it is that one more problem we had was that we didn't have a encoder on the motor, which was present, which was running on the mixer. Now this is a mixer which has a motor running on top of it. Now this motor was not required for us because we only need the part of which is the rotational part of it and how the blade would look like. Now when you see the blade, this is a very complex blade, like the curves and the movement that is present across. Cleaning them, because they are not flat surfaces. Cleaning a flat surface would be easy. But when it comes to the curvatures, that is where the underlying problem lies, and how do we solve them? So what we wanted to understand was what is the position of the blade, and important is for the eyes and the hand to coordinate. Because as a human, if I close my eyes, I won't be able to pick where is the bottle. I will shake my hand here and there and then find the bottle. That is how I learn, through my senses or my other part of the arm which has the sensor or a skin. So basically the robot is like my hand itself, so which can understand whether I'm touching a hot surface, whether I'm touching a surface or not. So I need to have eyes for it to know where is the distance, what is the distance be, what is the rotation that it has, and what am I seeing, so that whether there is dirt, should I clean it or not. It should understand based on the real world situation. That is the automation part of it. So we kept a depth camera, which is a OP, and created a 3D structure using a 3D printed cases. And again, 3D printing is a very important technology for us. Again, in 3D printing, a lot of models needs to be created using Blender, but each and every measurement is important. As you can see, we have measured each and every places, saying each of them is about 10 centimeters. So we know from the tip of the mixer, at what point is the camera located, what is the angle at which it is turned across with respect to the bisection or the cross section of the column. So we have made very, very accurate measurements across the system in order to say that the real world, if I put a camera on the mixer, in the virtual world also the camera is present at the same position. That is the whole idea. We should always remember, whatever I'm doing, it's the 1:1 replica of what is present in the real world. Simulation world is created once we build a real world and then take all the components from the real world and bring it into the virtual world and then try a simulation. So if you build a robot, you can build a robot and understand the robot through your system, but giving it out for research or for education and all, we don't need to give robots anymore. All that we need is to give them a simulation software with a URDF file. That would help them out to implement it in any of the software that they are looking into. So the whole step of this recording was to capture the spatial and temporal data of the blade and identify the rotation. There are 3 blades, which is rotation in a sync, which is a planetary gear system, which means there is only one gear system and the entire mixer is running on that particular motor itself. So it's a planetary gear system. So we are using OAK-D, that is the RGB plus the depth, in order to create the point cloud and also understanding the textures of it. Next, we are using the Unity and OAK-D SDKs, again coming from the ROS and the simulator, and sending these data into the robot which is present and designed in order to perform certain actions, which is like my hand. So I am doing all the activity of thinking in my software and telling the ROS to say what it needs to do so that it can simulate it without collision. Now, the next part of it is to record and synchronize the depth and the frame and the UI features. UI features are very important because you cannot give out a software to the users where they have to write lots of codes to run it. Like for example, write a sudo app code, run this particular code, run this particular code, run this particular code, start, do this, all. So they can't be able to do. As a user, when we think about it, user just wants a button, start and stop. That is the minimum thing that he wants. But we have a lot of complex UIs, which you would have already seen in MATLAB, in Python, or in any other kind of lab use softwares. So here we are going to create a new software itself, like a LabVIEW or a MATLAB or a Python, using these libraries which is present across. So here the important is the color stream. So the color stream gives us the color RGB values of it. The second one is the depth stream, which gives us the 3D motion of it to say how the entire system is present. And then we merge the left and the right and the bottom, all 3 of them synchronized in order to give us a point cloud for us. So we are going to use 3 different aspects of it. Now, so here you can see how a point cloud would look like and how a blade is going to rotate. So now in this system, so here you can see that every time my blade is rotating at a certain angle, I am getting a point cloud data which is coming across. Now this point cloud data has an RGB also and also has a depth texture also, which is shown across here. And these are all the frames of each particular thing. One is frame 0, PLY, frame 0. The frame 0 is the RGB data, which only gives you the texture value, that is the color. And the PLY gives us the point data, how much depth it is away from my camera. So from my eyes, how far is it? What am I seeing first? What am I seeing next? What am I seeing next? So it gives us that layering of those data. Now, this is a complete data which we are synchronizing. You can see holes and everything present, which will again be eliminated while we go on to the next step. Now, the next part comes up is that I am already looking in the previous section, what is the real world robot would look like, what is its rotation. Now, once the blade is rotated and stopped at a particular angle, to say there is a lot of, the eye sees, for example, the human sees that there is a lot of material present on the blade. So now I have to clean this portion. So what he does is he just clicks on, moves from one frame to the other frame through the PLYs and sees the texture and says there is a, if he finds out that a human automatically, actually it is done automatically, but I'm just giving an example of how a user would think. It's just that seeing that there is a format of like a clay or something present on top of it. Now I need to clean it. So now once the frame is selected, so we need to match the frame of the real world to the virtual world, because the virtual world doesn't know how much to rotate, how to rotate, where to rotate. It doesn't have any current or voltage being passed across it to make it to rotate and all. So we need to tell it what is its orientations and what is its positions. So giving out this is the very important part, which took us a lot of time. About 3 months of time was wasted on this, just to understand how to understand the image and skew the blades to come and sit at a higher accuracy of 99.99%. So to say that whenever I find out that this AI is running in the backend and says that the image in front of me is the blade 1 is rotated at 60 degrees, blade 2 is rotated at 75 degrees, blade 3 is rotated at 90 degrees. Saying this particular angle 60, 70 and 90 has to be very accurate and to be tested aloud tested along with huge amount of camera point views. And again, there are 4 cameras which is looking at this particular blade, and all of them are synchronized to tell 4 different actions. To say, I say 61, it says 62, it says 63. Some of them might not work along with each other and say, I don't see anything. So the best of 2 cameras, which gives us the highest confidence and gives us the result of 99.9, is what we are looking, because we couldn't achieve 100% at the end of the day. There will be a plus or minus 0.1 or 0.2 degree of variation from the real world, which can be eliminated with the robots and the other algorithms that I'll be looking into. Now, once the point cloud or the blade rotation is analyzed, so we capture the each positions and we understand how the point cloud would look like. Now, this is how one example of how the point clouds are arranged. Now, you can see that they are arranged in a particular manner, as you saw in the model when I showed the square boxes which was created. So it is arranging in them in the center of that particular box, saying that this is the first box, second box, third box, fourth box, fifth box, and so on. Now we use a particular algorithm called KD tree. So this KD tree, what it does is that it understands the scanning system, like for example, how Xerox or other thing is done using a raster scan or any interleaf scan or so on. Right. So now there is one more scanning method, which is a KD tree, which can help me out instead of doing from left to right and right to left and doing an ON number of operations, O of n number of operations. I can reduce it to half of it, because it does randomly. It does randomly and sorts it out in a way that I know where I am starting from 1, 2, 3, 4, 5, 6, 7, 8, and so on. And my tree is ready to say I can move from left to right from this, right to left from this, and so on. So that is where the KD tree algorithms comes into play. And this arrangements is very important for us to say what is the end effector position. I was talking about IK and FK, right? Now these points are the end effector for me. To say my end effector has to touch these points at any point, and also has to apply a force also, because to cleaning it is not easy to say I'm going to clean the robot without force or no force. So I need to apply a force on my hand in order to push the material out or a clay out when it is stuck on top of it. So these points are the end effector positions of it, and on top of which the robot is going to move across. Now, and the robot itself doesn't know the next part of it when we are going about is to say, how am I going to align the robot hand in order to go through these complex surfaces, because it cannot go straight, right? It has to turn its hand, go and approach it in a proper way. So the approaching, for example, if there is a coffee cup and it has a loop in the side, you don't want to hold it like a flask and drink it. You need to hold that particular loop and find where that loop is and turn it towards you, and then you lift the coffee cup. Now that is a kind of accuracy that we want to do, where we want the hand to orient itself to these points, which we call the normals. So the normals are very important in this situation to understand what is the robot approach point towards these systems. So we'll be demonstrating this about each and every step, how it's going to work across. Now, in the real-time capture, to summarize the entire steps that is being given, it is being summarized in this single block diagram, where we have an OP. It collects the point cloud, and it is a distance that is trying out the distance within the box of where the blade is present. So we have a virtual box, which we say within this, the blade is always present in that area, because it's a fixed place, right? Now you understand it's not a moving object, it's just a fixed place. And I am trying to view that particular angle in an FOV. That is a focal point of view. And once I know the angle of FOV and the distance is already calculated between the center of the blade and the camera. So maintaining a lot of geometry, we know where the blade stands and what is the area in which it covers. So now all that we have to do is read the point cloud data of the real world, convert them into the virtual cloud point cloud, and align them into the digital twin. So the digital twin and the virtual world should match with each other. So the method that we use across is the batch retrieval, which is the best match using the GPU. This comprises of a test point cloud against all the referenced of the cloud, which means that we have collected a data set using the OPD for about millions of frames. It's not one or two. We have ran it for weeks together, 24/7, where the camera is just rotating and recording and recording and recording and recording. And once at a particular point, I have millions of points, I can use this as my data set and start using this for my AI to understand how the point cloud is coming to make it faster. Again, AI is nothing but an automated system for me. It's not to say it is thinking, it's not doing any aspects of it in this real world, because we are going to teach what the AI is to be. Like, it's not like a chat GPT where I have a dictionary of English words and I can create sentences. So this is a separate problem, and we need to create a separate data set for it, and the data processing and everything, which I've shown in the previous slide. So we capture, we create data set, we have millions of frames. Now a new frame comes into it. We are using this new frame and trying to match to these million frames using the KD. Again, the KD tree algorithm shortens down what tree needs to be selected, how the tree needs to be built, what is the point of intersection in which the data has to be set across, because not all the 1 million data has to be run across. We just need a region of interest or a feature extraction, all of this which is running in the backend. I don't want to get into details of how we do this, finding the best match using GPU, but it gives us the orientation of the blade. Now, once the orientation of the blade is given to us, the next part is to the alignment of the scene. So basically the digital world gets aligned to the virtual world, that is the real world, and we have set the camera position, rotation, each blade quaternion is known. And again, you guys have to learn about what is quaternion. Quaternion is a 4D rotation, like how you see a roll, pitch, and yaw, which is not absolute with respect to the world, but when we go into the field of like the planetary systems and everything, the 4D makes more sense for us. Like, what is the position of Earth with respect to the sun, with respect to the Milky Way galaxy, with respect to the center of the space, right? So there is always a new dimension added on top of it to understand where it goes. So you need to know what is quaternion. Quaternion is again XYZ with a W, which is nothing but the roll, pitch, yaw, which is being projected down onto a 2D map. For example, if we have a Earth has a XYZ rotation, and if I open the Earth into a 2D paper like an A4 size and flatten it over and project them onto that paper, that will be the fourth dimension. So we will be looking into how the fourth dimension also works, because very important for us in order to create absolute rotations and absolute positions than giving the raw rotations and angles, which is the Euler angles when compared to the quaternion. Euler angles are not good because it leads to the singularities at certain point, which is not valid in robotics. Singularities should be eliminated. So quaternion eliminates these singularities. So wherever you have roll, pitch, and yaw, it's only for a single kind of a game. Like if you are using it on a phone, it works. But if you are connecting two phones together and making it to move from one position to the other as attached to each other and use two phones to control something, there you need quaternions. So what does the capture represent? Each frame is a is a snapshot of a point cloud, rotations, camera point of view, and we understand rotation, relative orientations of the blade, and validate this physical with respect to the simulation world that we have created. Let me just go through it faster and show you how this actually works. So now here you can see my digital in the white format, and my real world, which I've captured from the blade, is being projected on top of this. Now what I need to do is that I need to align my virtual world with the digital world, which I have got across after all the process that I have spoken about. So it just creates a virtual and a digital twin aligned here, where you can see a highlighted materials present across, which is just getting aligned with the real world. My entire 3D structure turns and rotates in order to align itself, in order to have the best match. Now, there is a step-by-step process of how we do it. So now when we are looking at it, you saw the first motion where I show the inverse kinematics, where I was moving a target and the entire robot is to follow that target, right? Now here is a target, and what is a surface? Now you can see that when I'm capturing the point cloud data, a lot of other data has also come across, which is the column, which is the camera, the other parts of the system also is being captured, because it is a conical frame that I have been taking across, and this just spans across the entire system. So I need to cut it out. That is what I was saying. We have a rectangular bounding box system which tells me where is the blade. Now once the crop is done, so you can see that once the point cloud is got and the point cloud is cleaned up, the point cloud surface is as shown here, which has millions of points. Again, it depends on the number of points or the scan surface that we have got across. Now, each of these scans has a multi-points arrangement across it. Now you can see how the points have been arranged here. They're not straight lines. They might be crooked. They might be in curved surfaces also. Now this is the complete step-by-step process where you can see that we are going to extract a point cloud using our point cloud extractor script. Now here the point cloud would be like, as I told you, this is a robotic arm. This is my blade surface, which I want to clean across. But there are so many other things also, components present here. So now as I move across, so you can see that so I'm going to run a particular command which says crop. Now, once the crop is done, so you can see that the only surface that is required to generate the surface is the blade surface, which is actually present there. Now, the digital twin is still present, but the only surface that I need to clean is these blades. So that is what I'm selecting across. As everybody understood how we create a digital twin, how do we bring that into the virtual world, and what are its importance, and what is the best way of creating a digital twin is using your iPhone Pros also, which has a LiDAR, only Pro features basically. I also use iPads for iPad Pros in order to create the GLTF file. From that I can extract the mesh. There is lots of options present to you using an iPhone. Again, if you are willing to invest in a LiDAR like a Hikaiku LiDAR, or it might be any other Google LiDARs that has been come across, a Tesla LiDAR that is coming across. But I would say Apple is the best one right now, available, affordable, and also it's on your phones. Most of your phones would support if it's a Pro version. So you can use this system also in order to capture this system. As everybody understood the point of digital twin and how it is created. Any questions? So can we move to the next topic? Yep. Okay. So the next topic is to create the robot itself. Now, what is a robot that I'm taken into consideration is the UR10E. So UR10E is a universal robots, which is UR mentions the universal robotic arms. And in that I've selected a particular robot, which is a 10, and the series is E. There are a lot of series. Now it's gone to 30 series, but I'm still using the older one, which is the 10 series. So which is again programmed, designed, developed. The entire software architecture is being developed by us and not using the universal robot software at all. All that I need is the hardware, because as we know, in India, we don't manufacture harmonic drives. So we have to source it out either from Taiwan or from China or from Japan or from US and so many other places. But we are not able to generate harmonic drives. We don't have this capability of designing or creating these harmonic drives. It's not a servo motor. It's not a stepper motor. It's a much more higher accurate motors, which can go up to a level of 0.001 nanometer also with respect to the degrees that we provide. So the smoothness and the kind of torque it provides is at a very high rate with a very small motor, with a small size. Like the kind of industrial motor that we use, if we use harmonic drive, the size of it can be reduced to 1/10th of its size, I guess. So that is the power of harmonic drives. So I would also want you to look into the concepts of harmonic drives, about its accuracy, about its encoders, and the use cases also. So now I have used about 6 harmonic drives to create this kind of a robot, which follows the UR10E system itself. So again, we created a URDF file. I hope you know how to create a URDF file and so on. And also FBX, convert that URDF file into an FBX so that I know the pivots are very important. As you know, the rotation of the blade, how it has to rotate, where it has to rotate, where is the center of the blade. Everything needs to be mapped in the digital world, in the virtual world or in the digital twin as per the real world. So if you move an object, there is a pivot for everything. The pivot is the point where it's about to move. So that is very important for us to understand. So the configuration of this robot is a base, shoulder, elbow, wrist 1, wrist 2, and wrist 3. So it is a 6-axis robot, which gives me a 6 degrees of freedom, and it has a payload. It has a payload capability of 15 kgs, and it can put a thrust of about 1000 newtons in force in front direction. So which means I have a very good force. I have 6 axes to work across with, because I showed you a 2-axis IK system. Now I'm going to create a 6-axis IK system to make it work on it. And their shoulders and joints are shown across as shown in the image here. So which means that it has a world position, it has a base link, shoulder link, upper link, forearm, wrist 1, wrist 2, wrist 3, and so on, as per your arm. So you know, from the shoulder till your wrist, you have a configuration of 3-1-3, which means you have a 3 degrees of freedom on your shoulders, you have 1 degrees of freedom on your elbow, and you have 3 degrees of freedom on your wrist. So that is a kind of a system which humans are using across in their arms or in the legs. When it comes to the legs also, we have a hip has 3 degrees of motion, knee has 1 degree of motion, and the ankle has 3 degrees of motion, which helps us to balance out and gives us lots of orientation and position to work around in order to do a balancing, which means more the number of links, better the balancing that we can do across. If you just have 2 joints, you cannot balance only, because you don't have the yaw, pitch, and roll in every single position. In case of ankle, we need that at very important to stabilize ourselves, to know how we are going to work on it. So we cannot have a robot which has just 1 motor on the ankle and say it will balance. That's not possible. It has to have 3 motors. It has to have 3 degrees of rotation. Similar way on the hips also. You cannot have only 1 degrees of motion. That means our gait is going to be very bad. So we are not going to be able to lift our legs sideways or forward or rotate in the same direction. No, so that is the difference of why the number of links has to be selected. Now, when I was talking about the IK, I was talking about a particular IK called cyclic coordinates, right? So now, here is one example where I'm showcasing how the cyclic coordinate of the axis would be present. And when I call the pivot, you can see that I have mentioned X, Y, Z of each point. Each point matches to that particular, where the red is the X-axis, blue is the Z-axis, and the yellow color is the Y-axis. So you can see up, forward, up, and side. So 3 different axes of every time position. It has to be uniform across each robot when we create these axes in the digital twin. So we need to position the axis in such a way that this is the coordinate system that I am going to follow. It might be a left-hand rule or a right-hand rule. It depends on what rule you use across, but that particular rule has to be followed uniformly. There is no hard stop to say that you have to use this rule itself in a coordinate system. It is better to match it to the ROS coordinate system or to the gazebo coordinate system, or also to the Unity coordinate system or Python coordinate system. In whichever the world coordinates is present, you need to create a coordinate system which is at the center, which is at 0, 0, 0. Now you can use the same coordinate system which are present at the 0, 0, 0 to be present across the system, so that it will be easy for you to align them according to the world that you have created. Now, here you can see a cycle that is present, which tells me that it is going to rotate in that direction itself. Means it is going to go up and down like this. Now here, when it is flattened on the ground, which means it's going to rotate in the particular direction in anti-clockwise and the clockwise direction. So there are 3 different directions that you already know, X, Y, and Z, as mentioned in the coordinate system. It's going to rotate in that particular. Here it is rotating in X direction. Here it is rotating in Y direction. And here it is rotating in Z direction, as you can see. So there are different directions in which we can provide based on the axis that is pointing out. So this rotation results in Z direction. This rotation results in X direction because this is perpendicular to the X axis. Here it is perpendicular to the Y axis. So you can say whichever axis is perpendicular to that particular cyclic coordinate, that is the axis that is the revolution of this. Yeah, and I was telling that we are going to implement a CCDIK, and this is an important step for us to understand how the cyclic coordinate works. So let's go into the system and see how a cyclic coordinate would work and how this will help us out to understand. Now, with the help of cyclic coordinate, you can see here how the robot is going to move from the target to target and have a common position in 3D. So this is a 3D world that we have created, and the robot is moving across in that direction itself. Now, now you can understand the entire stitching of the system, how we have architected this entire software. The robot is a separate work. The digital twin is a separate work. The algorithm that is creating those things are the separate work. They don't need to work together. So you can always create an architecture where you can assign a small portion which is independent to each of your individual students when you conduct these kinds of projects, so that they don't need to worry about that I have to make such a huge software. Instead of that, breaking them into a smaller layers which is independent of each other but still works. Now, instead of this block which I am using across as a cube, now if I provide just the point cloud data which I showed in the second or the third slide, where there were numerous points and I pointed out to say these points are the XYZ points present, imagine what would the robot do now. It knows that it has to move from that point to the other point, other point to the other point, other point to the other point. Now this becomes a waypoint systems for them. So it just follows these waypoint systems. So my goal is to say, what is the selected waypoint system that I have to send to the robot in a right coordinate system so that it can clean the entire blade surface which is already known to me. That is all the problem, and this solves my 90% of the problem by saying robot is ready. Robot is ready to move on the blade. Now, but I don't know the actual position of X, Y, and Z. So let's see how do we establish the connection. So the connection is again very important because there are numerous amount of hardware present. The camera is present, 4 cameras. There is a sensors present across. There is a software running. There is a LAN ports. There are so many other things running. So how do we connect them all across? So it's very thing that we can use a dual socket, that is TCP/IP connection, which you can define multiple ports for each of them, saying a static IP for the first camera, the second camera, the third camera. You can allocate IPs to it. You can do various ways of it. So it is up to the networking team who understands about what is the networking protocol I'm going to use in which I'm going to publish the data. So there are multiple ports, like I'm using 30,002 for robot to send data. I'm using 30,003 for robot to receive data. I have 30,004 for exchanging the real-time data exchange keep happening over there. I have a UDP port also to just broadcast a particular message saying I have a force. I have a force ended on the blade surface. Like this, we can have multiple ports opened up for a single software so that we can communicate parallelly instead of waiting for a particular thing to come across, which I see is very important, which normally people don't use across, and they fail in this situation, because communication and the thread logs and the thread opening is very important, because most of the data is important. It depends on the previous data itself. So if the data is not coming, the entire system has to halt and wait, and my fixed update gets what do you say? It gets messy. So the timing might not be 1 second every time. So it might be 1.5 seconds, it might be 1.2 seconds. The update keeps happening and it varies. So my timing also gets, the clock will not be synchronized. So in order to keep this clock synchronized, we need to have multiple threaded programs and see that there is a common atomic clock. So normally, atomic clock is something that is present. You can look into the Google, where it is a standardized synchronization clock on the cloud, which you are running. And there is a single clock and all the components are looking at that clock itself. no other clock, because if there is one clock only in my system, I know exactly what is the timing I'm hitting what at what time. And everyone knows when I have this clocking timing as a important, because when IK is doing, there's a lot of competition that it has to do, a lot of iteration it has to do. What timing it was able to understand the iteration, how can I reduce the timing and bring it into a synchronized way. So that is where these kinds of ports are very important for us in order to understand the communication part of it. Now, the real-time motions can be done with three major commands, which is going into the ROS. That is the MoveJ. There is also based on MoveJ is called move joints. So I'm doing forward kinematics in the virtual world, but I'm doing inverse kinematics in the real world. And I'm doing forward kinematics because I already know everything in the virtual world. I know what is a path. I know what is the planning that I have to do. I know where is the end effector. I know what is the joint angles. I know where the collision is present, where the columns are present, what I need to avoid, what I need to keep. Everything is known in the virtual world. So when there is a full known communication, or when you know the entire variables and everything is constant there, you can start using forward kinematics because it is simple. As I told you, the iteration will be very less in the forward kinematics, but whereas in the inverse kinematics, it becomes complex and complex because all the 6 joint angles has to be calculated. But whereas here, I am calculating the end effector with the joint angles present. So that is the reason why I use MoveJ. And there are also much more other system, which is like a speed J and servo J, where you can control the speed of the motor or use the servo system of the motor. It's similar to MoveJ itself, but in a slightly advantages. For example, speed J will help you out in situations where it's like a pick and place, where you need a constant motion being applied in a repeated way. But whereas in my case, it's not the same thing that it will be approaching. The approach keeps changing every single time the blade is dipped on the fuel and comes up. The fuel might be in separate places, and we don't know what is the kind of system that we'll be looking into. So we need to create a custom motion planner now, which is not present again in libraries. So when it is not present in libraries, how do you create it and how do you put it across? That is next question that we need to understand. Now let's understand what is CCDIK. CCDIK is cyclic coordinates descent. That is basically you've seen in the robotic where I show the cyclic system that is present across to solve joint angles based on the target position. And the next thing is it captures the waypoints for the blade point that is present. Means I am going to move my robot every single point in the virtual world and run a cyclic coordinate IK and understand what is its joint behavior, whether it is the right behavior or not. If it is not the right behavior, I rerun the iteration and say it is rewarded with a negative point. Unless or until all the links gets the positive points, it doesn't move forward. So it keeps calculating 1,000 times, 10,000 times, sometimes even more than that. So unless or until it gets the best waypoints, it doesn't move forward. So it keeps doing the system again and again. Now, UR script is a very important concept that we need to understand, which Universal Robots have given. They have created their own software, which costs about $10,000 per year as an SDK license. Now, when we come to the part of ISRO where we are implementing UR robots, because we don't have, again, harmonic drives are not present, and I don't want to get into the hardware manufacturing. So we want to use those robots, but not use their softwares. So because the softwares are the ones which kills the entire purpose of it, right? So the software is very important because that is the brain of the entire hardware. But the hardware is quite easy. It's an harmonic drive. They have given out UR script, complete SDK of it, to say these are the commands that you can use in order to move the servo. The servo has few APIs. The harmonic drive has APIs across it, which you can use across to send commands. Now, this is what supports us acceleration. We can create a timing loop to say look ahead of different 10 multiple points and then plan your trajectory. Look ahead 1,000 points and then plan your trajectory, because we want to touch each and every corner of the surface. So that is where the acceleration, velocity, and other parameters present, speed, everything comes into play using the UR script. It's an advanced programming system which we have to learn across. So I'll be showcasing few of them. think I've spoken about this definition of, yeah. So next is now once the entire system is aligned with the virtual world, because of the camera alignment, the point cloud, everything matching is done, we will run a particular raster algorithm, which is zigzag path, which is normally a path for the robot, which has to go from one end of the point A to the other end of the point B. So when it has to move from point A to point B to point C to point D, and so on, and follow a particular force also on top of it, because it has to apply certain force and not only touch. So we need to keep understanding its parameters. Now the raster scanning is all about sending like a light. It's like a LiDAR. You are going to simulate the LiDAR on a turtle bot is different. For the LiDAR of what I am talking is different. I don't have a LiDAR in a real world, but I am creating a LiDAR in the virtual world, so that I don't need the hardware anymore. I don't need that particular hardware to be present in the real world at all, because I know the components, I know the things. I can run the LiDAR in the 3D world itself and then make the robot move in the real world also. Now, how is this possible? For example, most of the cases where we want to reduce the hardware, again, battery consumption, the kind of algorithm it has to execute, the boards, the power that it is using, everything has to be brought into a particular case study. So when we use that, people don't like too many hardwares on top of it. Like, for example, it might be the vacuum cleaning robot. So if you give the dimension of your house, which comes on your blueprint. Now, if you give the dimension to the robot understands that this is my house, this is my home position, and if I move from here to here, I know my boundaries of it is 14 feet forward, 15 feet in wide, 17 feet in width, and so on. So it knows exactly how much is my dimension, and it can do an odometric analysis on its own and doesn't need any sensor in order to avoid any of these systems. If it is static only. If the dynamic is environment, if the entire system is dynamic, like for example, when we are going to Mars or any other kind of a system where we don't know the environment itself, that is where LiDAR comes into play. So now I am creating the LiDAR in the virtual world to eliminate the LiDAR usage in the real world. So what it does is it just spans millions of raycasts onto the blade and finds out what is a suitable point I can hit on top of it on my crop data, that is the blade surface in the virtual world, and start creating a raster scan to go from left to right and right to left, and stick a point or put a timestamp of equidistant points on the blade. Now, because I cannot use millions of points and send it to my robot, because the point cloud has so many points, but I don't want to send all of them. All I need to do is to reduce that so that it also covers it up and the resolution of how much it has to move. So I can create an equidistant point, assign a timing to it, assign a velocity to it, assign an acceleration to it, and so that it moves from one point to point A to point B to point C, and so on, and keeps moving across. So that is the entire system. So here you can see how a raster scan algorithm works. So here you can see I've created an entire snake kind of a system where the algorithm creates a complete normals of the system also. What is a normal is the red line that is present. That is the approach of my hand, like how my wrist has to rotate in order to approach that point. So it's not only the point, because if there is only the point means I go and hit through the surface and I will not be able to align with it, because it is curved surface, right? When the surface is curved, you have to go in a parallel direction to it. So how will my hand go and approach onto it is very important. So this point tells me that these are the surfaces that is available in front of the robot, how it has to move and how it has to collect this data and create a path planning on top of it. Now, real-time feedback is also important. What is the real-time feedback? It's saying that my end effector has reached that position, I want the next point. My end effector has reached the position, I want a new endpoint. So I have queued n number of points, and I am telling in the feedback to give me like an acknowledgement to say, I need this. I have given 1 point, you give me an acknowledgement of the second point, given the first point, give me the acknowledgement of the third point, and so on. So this is like keeping the track of the previous window as well as the current window and the future window also. So this will help me out to analyze what is my future points coming in and how I have to adjust my normals of my wrist in order to get into that position. Now, again, I told you UI is very important because people don't like to see all of this running on the code, like I showed you on by executing one by one. All they want in the UI button is click connect, the robot should be connected, click home, it goes to the home, click key pose, it stands in its key pose. I reset, everything resets. I just have to click on few more buttons, real time toggle. When I click on real time, the entire robot, the blade rotates, the camera picks up the system, cleans the entire blade, creates a register algorithm, and as soon as I click on the start button, it just starts cleaning. So this is all the motion that people on the ground have to click on, who are the ITIs or who are the users. Basically, they don't need to know what the software is written. They just need a proper GUI in order to use it very easily and autonomous way. And force feedback is very important because we need to understand the force shouldn't exceed more than 200 or 300 Newton. That is what is a parameter that you are going to set based on the conditions that you are looking into. So we can also look into that part. How do we get into this? So now let us get into the simulation of it and see how this will work.
Simulation.
The first thing is you have to get into the browsers and go into a particular system called Polyscope UR. This is the Universal Robots. So you can just open your browser and type on Universal Robots and get into their e-learning courses. Now in the e-learning courses, they are showcasing you how is the future? How is the future of robotics being programmed? Now, if you see the kind of textures, the kind of digital worlds that they have created here. Now, these are all present as a hardware setup, how to use it and everything. So here you can learn much more in advance about how to use them. And there are also video tutorials also for you available where you can actually get into each of these tutorials to understand how a programming can be done on for various kinds of pick and place robots. Normally, they're not showing any cleaning system. They're only showing the pick and place. So now one more thing that I want you to download is the Polyscope. In order to go to the Polyscope, you need to go into the particular link which I'm sharing across on the chat. Where is the chat?
On bottom right side, sir.
Yeah. This is the first link. This is the second link. And now, once you install this based on the kind of system, since I'm using Windows and not using Linux, so we have a Polyscope which I have been showcasing here. This is how my Polyscope would look like. Now, this Polyscope is like similar to what you have used in your gazebo or any other kinds of a simulator that you have used across for robot. Now, here, what do you see is so here you can see there is different robot. Now this is a Polyscope robot which is created. Again, it's a simulator for UR10E. So the simulation is actually, you can download it from this. So if you download this extractor and create a virtual environment of your Oracle or any VM box, you can use it. You can mount that image on top of the Oracle. So as you can know, you can just click on the first image, you can click on that and you can click on start. And once you click on the start, it just runs the entire image of this and gives you the real world robot in your hand, which means that whatever I run on this robot on the Polyscope that I'm showcasing will be the same as what is running in the real world. So there won't be 1:1 match of what product they have provided. So every single robotic company, it might be Kuka, it might be ABB, it might be UR10, everyone have provided their own ROS simulator like TurtleBot, like how a TurtleBot physics is being calculated and put across. So this is one of the simulator that you need to look into, and you can download it. It is about 4 to 5 GB, and you don't need to install it. You can run it on a Docker. Docker is the best way to run it because it is faster. But if you have a VM, you should have a separate, it has given a separate list of how to install it and how to do it. Okay. So I'm just going to cut this off. And now we are going to see how both of them are going to interact with each other with the UI. So now when I was talking about the UI, so what is a UI is all about? The UI is all about to say how easy the system is made. Now, for example, this is the UI which a user is going to use. Don't you think it is much more easier to say, connect the robot, start the camera, start cleaning? You see, this is what the people want, but the underlying algorithm, what I explained, is present. Now, if you go back, what is behind the scene? The behind the scene is this. The behind the scene is basically has a 9-axis robot, which is again custom made. So we made this robot to lift about 21 feet high, go into the system and create a UR10 robot which handles all the system onto it, creating a digital twin and each of the blades also. Now, as you can see, the pivot of the blade is being arranged across here, which means it can rotate in a particular direction itself. Now, it can rotate in a particular direction itself. So now there is each and every robot that you are seeing across here as a system across it. So now let me show you how it's going to work across. Let me select the robot. So this is nothing but the UR10 mesh that I have created. So I have created a new FBX model out of it where I want to combine the UR10E with my 3-axis. So it becomes 9-axis model, which means it can push it up, it can rotate, and it can go forward and back. So it is a 3-axis here and 6-axis on top of my system. Now, this has a blade also, which means it has a Teflon blade, which is again coated with so many materials so that it is friction free and other parts of it. Now, each of this has a particular joint. When I call the base joint, so this again, I was talking to you about to say how should be the pivot of the base joint. This is how the base joint would rotate across the axis. Okay, and next the shoulder joint, and so on, and the elbow joint. Now you can see the elbow joint here, W, it is always present in a particular angle when it is, I'm keeping it at calibration. Now it is at home position, but it can rotate up and down. So this is the simple way of changing the x-axis, y-axis, and what is the axis that we are running. So as I always gave you in a cyclic coordinate system, I have an axis defined for it, and perpendicular to the axis, I'm running all the rest of the things will be 0, 0, 0. It doesn't consider what is the minimum angle and what is the maximum angle. And this entire system is again an SDK that we have created for the UR10E by ourselves. So this entire base robot, I will be putting it on the Git and sharing across to you with some of the robot examples that we have done so that you can also follow and use this in order to connect to the ROS. Now, a few more things that we are looking onto is how do we connect the OBD camera and how do we connect most of this. And this is also important for us because most of the things that we are running across is again on GPU. So I want more of my things to run on my GPU than on my CPU. So we have modeled it in such a way that it has to run on the GPU itself. So let's go into the system and see how it does one by one by one. So initially I had captured, now here I only captured 1016 frames, which means the accuracy will be less. But in the actual world, we have captured millions of frames, which means every small minute motion of the blade, I'm rotating it by saying 0.001 degrees of each blade. How much, what is the action? 0.002, what is 0.003, 0.004, and so on up till 360 degrees. So until it becomes 360 with 0.0001 increment, I keep moving it and capture. So I'll have multiple frames across it. That is where the recalibrate thing will work for me. And the digital twin is a much more easy thing for us. So let me just show you. So now I want to connect it to my program here, which is running on the ROS. So now what is the important step here is that you should know its IP address. So when you click on the about, you will be able to see the IP address. Since it is running on my local host, it doesn't have an IP address which it needs to have. And you can use this if you are connecting it to the real world robot, it will show you a particular IP address as 192.62.168.5 or something based on the network that you have provided onto it. Now, the UR10 of this particular has few major inputs that you can see. One is the home position. So what does it do when it is going to the home position? What does it do when it is going to the other positions? Now, for example, if I bring down entire thing to 0, so now you can see how the robot automatically moves to its position. You can move the entire robot, which was in the home position, to go to the 0. Now, this is the actual position of where my coordinate is matched. So when I put 0, 0, 0, 0 in all my joint positions, I want my real robot to be like this and my virtual robot also to be like this. So this is my reference of the calibration of what I'm going to do. Now, for example, if I give 90 here, so it is going to move that much. So you can say, I'm going to move my robot to a particular motion across here. So now in a similar way, we can also start running it, sending the same commands from any software. It doesn't need that you need to have Unity, Python, or any kind of a software. Even a .NET code might work. This is just good because of the display, because of the kind of enrichment on the UI that you see across is what is being given across here, and ease of use for the people to work across. Now, when I start the project, the first thing I am going to do is connect it. So there is a particular IP address which is already connected onto it. When I click on start, it automatically starts the entire system here. As you can see, power on, everything being done, and stop. Now, what happens here exactly is that here, when I click on, there is a sequence in which it does. It has to boot, it has to come robot active, and it has to start. Now I'm going to turn it off. So it is basically in the off state. Now, after I click on the start, what happens? So there's a command which we send across, which does this particular job. And as soon as that is done, the robot is automatically set to active. So this helps me out to send commands to my server, which is the ROS server, which is established in around 12 kilometers away from the actual station and is controlling the entire aspects of it. We can say what amount of payload, everything that is required on top of it. Now you saw the 0 position was something different that time. It has already come down to the home position now. Now this is what I call as the home position, because that is what I have put in my robot also has the home position here. You can see this is the position in which it is trying to match. Now the next step is to connect the base robot. The base robot is this. So this is a separate entity. This is a separate entity. I need to merge them, which means the motion of this should relate to the motion of this. So I'm going to start home position, cleaning position, and then start a camera. So when I start a camera, you can see that my OD, whatever it is capturing in the 3D surface, is present here. Now, when I click on start cleaning, and you can see most of my status is present here. Click on start cleaning, I can see here. In the digital twin, basically, I can start my fly camera and I can move across here and see the entire 3D world itself. How my 3D world looks like, how my 3D world is going to move, and so on. And this is the camera. What is the view that the camera is looking and how the blades are present. And important in this is that it's a mirror. Now you can see the steel surface are nothing but a mirror. So LiDAR won't work because LiDAR is again requires a reflective surfaces. LiDAR will never work on a mirrored surface. So you should always remember, black and mirrored surface, LiDAR is 0. It cannot be used at all. It's like pointing out, giving out a torch to the sunlight itself and saying, I am better, because it's not going to work out. So here we have to see that how I came across with this problem is that very easily I sorted it out, saying that I'm going to understand the rest of the environment and then understand where the blades are present. So now I'm going to click on the robot to go to the home position. I'm going to click on start cleaning. So once I click on start cleaning, what happens here is very important that you guys have to see. First thing it did was arrange the virtual world points to this particular surface. Now, if you see from the front,
Hello. Hello, Stafford. You are not audible. Okay. Dear participants, I think sir has got some network issues. We are not able to connect with him. So our second resource person is already there in the meeting. Okay, let me conclude the first session. I think he'll join soon after I get a mm, network. So from the organizing team, I would like to thank Stafford, even in his busy schedule, he would able to make the session. I thank Stafford Michahial once again. Thank you, sir. And we have the next resource person, Raghunandhan B. I think you already know him. We all he has taken the session on first day on the creation of ROS workspace, node creations, and all. Today he'll be taking a session on object detection using ROS2. I think one of the participant has messaged in the group also whether that topics will be covered or not. So he'll be taking object detection in ROS2, and also he'll be implementing that using a YOLO. So welcome, Raghunandhan sir, once again for the session.
Thank you.
Over
Thank you.
to you,
Ma'am.
sir.
Thank you. Once again, very good evening to one and all who are there in this today's session. Okay. Yeah, let us start with today's session. I hope the previous session was very much informative for you on the grounds of the development towards the robotics application in the especially in the domain of VR and AR. Okay. So yeah. So I hope post to my first day session, I think all basics till the creation of nodes we have discussed, and later on, so you have worked on, understood the concepts of even subscriber and publisher, those concepts as well. So before I start, I would like to just want to reiterate on that, because the same concepts I would like to use in today's session as well. Okay, so especially on the subscriber and publisher part, just want to explain only the programming, and because today's hands-on session, I would like to use the concept of subscriber especially, so that I would like to once again reiterate for you all. Just a moment, I'll be sharing my screen. I think I need an access to share my screen. I request the backend team to.
Yes, sir. Yes, sir. Sir. Now you can share.
Yes, thank you. Yeah, so rather than I'm using a presentation, I would like to directly show the code in the today's session. So quite important today. So I think day one also I have received various questions related to topics and so on. So very importantly, this I would like to give you a clarity on how things will work. Okay, so this is a very simple code to understand. Once you, because we have undergone how to create a simple node in the ROS platform, and the basic skeleton we understood, and then I started to explain you how to create a classes regarding the using functionalities of the global installation of the ROS packages. So here it's a simple node which able to publish some information. Okay, so there is a command called turtle1 / command underscore velocity. So velocity information is the main thing this particular node is going to publish. Okay, so where this publisher is getting created, everything I'll explain you today. That is what. So line by line, I would like to explain. I'll zoom in a little bit. So as usual, you know the code structure. So we have to give the path to the environment Python installation. That is one thing, the basic interpreter. So followed by, so we have to include this library. So since we have developed Python package, okay, so that's why it is very mandatory. So next is this also you are familiar. We wanted to use the inheritance concepts, especially the functionalities of the node when we create a node using the class of Python. So that's why we'll be using the functionality. That's why I'm importing this method also here, okay, through RCLPy itself. Okay, and see, if you, I'm just hovering the mouse and you can see there are a lot of information is also popping out. So this is possible only when you add extensions. Okay, so in the VS Code, I have installed VS Code. That is what we did even in the session 1 as well. So try to install the basic setup when you create any, when you use any editor, especially the popular editor like VS Code. You can convert that into IDE. So by including the modules by extension packages. So I've installed, if I go here, you can see the extensions, which are all the things I have included here. Okay, so especially since there was some lagging in my first class, I have just installed the Docker here on the main operating system here. I'm using 24.04. So in the first session I was using a virtual machine where I have installed 22.04. Okay, so rather than to avoid those all this irregularities during the execution process, I even 2 times the system got shut down. Okay, so that's one thing. So main thing is you have to include Python package very importantly. So I'm just scrolling down whichever the package is very important. See how to install everything also, I'll just show it to you. This is basic setup you need to do. Okay, so once you install VS Code, so using a simple command sudo snap install. Okay, so classic. So that is what the command you have used. So after doing that, once this VS Code got installed into your Ubuntu machine, so try to type the packages which you want to install, because you need to use Python. So use this Microsoft Python package you have to install. Already have installed here. Along with this, you need to use this one, AutoPep8. So this is Python extension package, especially this AutoPep8 is for especially the formatting the text or whatever the program you write. So for that purpose only it will be used. Okay, and that is another thing. So and also very importantly, you have to include a package called ROS. Okay, so I have installed here. See, earlier Microsoft also was supporting this. Currently it got deprecated. If you just click here, it will only suggest which package you need to install. You just install this Robotics developer environment. So why you have to install all these things? Whenever you type your code, okay, it will only help you to give you auto suggestions. Okay, so that is why. So once you install all these things, you will only get to know. For example, if I type here import, see, it is giving auto suggestion RCL. So it is giving every suggestions here itself. So try to make your IDE more intelligent by installing all these packages. So after installing this ROS packages, it can also detect all the commands of the ROS. Okay, so that's the reason when you're importing, it is also auto suggesting whichever the libraries, whichever the modules you need to import. So, okay, that is what it helps out. So I hope I have got the clarity. So once you installed, if you have already installed, if you have not done this, and so why my editor is looking like this, because I have installed these packages once I install this VS Code. That is one thing. Okay, now coming back to the code. So very importantly, this is the one thing I need to include here. So basic thing, I have created a main function here. I have just excluded that if condition statement to run the main. So without that also I can run it. It will work very nicely. So that is another thing. Yeah, I'm getting fine. So next is I need to create a simple. See here, there's just a node. I think this exercise has been already been done in second day. Might be program has not explained. So that's the reason I'm taking time to give you an insights on this. So I have created a simple class with a name, and I have inherited the module node functionalities of all the node. And so this is the name of the node. And here I'm creating the publisher. The node will going to publish some message, okay, such that so it will send some information. So what kind of information also I have created here in the code, I'll explain that as well. Once it is done, I'll share this code also. You can try. Okay, so very simple. I have just created this code next to the code which I have explained on the day 1. Okay, so I'll just show you that as well. So earlier code which I was created was this first node. Okay, this is the code I have just created. So in the same folder which this package got created, my robot my underscore robot underscore control. Inside this, there was a folder, same name. So inside this, only we were creating the nodes. Okay, so here only I have created another node. Okay, so which is acting as a publisher here. So in the constructor itself, you need to include means you need to create a publisher. So I've created just an attribute here with a name. So here, why I have created like this means here it is trying to send some velocity information. Okay, so how I got this all details. So I need to send velocity information only. I need to send some other kind of information. So it is based on already we have ran some basic demo programs, right? So we ran last session turtle sim turtle node, and also we were able to teleoperation node also. When you try to press a key, it was able to give some information. So because of these two nodes, with the help of ROS commands, okay, so I was able to identify what is the type of messages it was generating. Okay, so from that only I was able to get the information. It is sending velocity information. Okay, so this is what I'm trying to publish here. So velocity means what? I'll try to give you with a demo also. You'll come to know what it is. Okay, so I'm just printing that as well. The messages here, I'll show you that as well. So now, here this particular program will able to by using the turtle node, turtle sim node, I'm sending some information, velocity information. So here velocity information means there is a linear displacement, similarly angular displacement data. So that I'm creating here. When I say a turtle bot, so it is on a GUI platform. When I say the robot will be in a three-dimensional space, it will be having X, Y, Z axes, correct? So when it is a simple normal robot which is on the floor, so it can, if it's a two-wheel drive robot, so which is a differential drive, so it can have X-axis, positive X and positive Y. Okay, on the with respect to word coordinate system, okay, it can have both displacement with respect to X as well as Y. Okay, similarly here with respect to Z also, so it can also have an angular motion as well. So that is what that information I've included here. So before going to that, I'll just explain you. So I'm just using the publisher. So this is possible because of this RCL library. Okay, so by using this create publisher command, okay, I'm trying to send this type of data called twist data. Okay, so how I got this message, I'll also show you the information. And this is the topic where I need to push this information. So where I need to publish, because directly I cannot send any information from any node to another node. Through topic only I need to send. Okay, so this is the topic which is already been available in the demo. So that's why I'm using the same topic. So that's why the name should be properly I need to use. Okay, and this is the buffer number of information. So where, so at least up to 10 information I can send where buffer can store. That is one thing. So this is the single command where I'm creating the publisher, the node which can publish the information. To create a publisher, I'm using the command available inside this RCL library called create publisher. That's it. Okay, so remaining thing, and what kind of information I need to publish. So I just created the node as a publisher, but what kind of information I need to publish to this topic. So that I need to create with another function here, okay, inside the class itself. So here I've just defined a velocity information I need to send. Okay, that is what. So message type I'm trying to send is called twist data type message. Okay, so that's the reason I have imported this. Okay, so there is a message called geometry messages. Inside this particular module is available called twist. Okay, so that's why I need to send any type of any messages, means it should be in this format itself, geometry information. Okay, so that's why since I have imported here, so I have created a object related to the twist, and then I'm just trying to give the information towards linear X value and as well as a linear Z value. Okay, because my intention is to create this node such that whenever I launch the node of turtle sim node with the GUI information, so where the turtle bot is available, 2D graphics. So when I send this data, so that particular turtle robot should be able to draw a circle. Okay, so that's why. So when you take a value X displacement, so it will move forward or backward. So positive value I have given here in real number. Okay, so 2 I have given. So this is the velocity. Okay, linear velocity. So similarly, and this is the angular velocity with respect to Z axis. So it is also positive. Okay, where so your robot will take a 1-degree turn. Okay. So that is what, and you have to publish this message. Already have created a publisher, and it is available with this attribute. Okay, so self dot command underscore velocity underscore publisher. So using that, I'm publishing this message. Okay, so when I publish this, automatically it will push the data, okay, to the publisher, and then I have to set a timer here. Okay, because you know the purpose of why this rcl.spin is used. Why? Because it should this node should continuously active and send an information, okay, till I kill this node. So that's the reason. So once I publish it, again I need to call. So that's why I have a callback timer I have created. So this is what the timer which already we have experienced in the first class. Okay, so every 5 seconds I need to call this particular function, and I'm sending this velocity information. As soon I call this particular function, so what it will publish, it is publishing this message. So message carries these two information: linear value of x, which is 2.0, and the angular value of z, which is 1.0. Okay, this is what I'm trying to do. And once it is done, so this will be executed. Normally using, after building everything, it will execute. So post to this, once you create this particular node, in the same way how we have updated the setup file, so we have to update the setup file here. So setup file I have updated. So this is the executable name, and this is the package name, and this is the file name, and this is the main function I need to call. Okay, that is one thing. And if you observe here, the name of the file and the executable name and node name. Node name where I have mentioned, if I go inside the program, the node name, all the names I have kept common. Okay, same. You can also make it, you can also use different names also. But when you are using this in the setup file, you should be very, very cautious. Okay, so I can show you that example also, because day one I couldn't get the time to explain because my system got crashed. So here, for example, I have gone to the previous day's program. So node name is my underscore first underscore node. Okay, that is one thing. So, and the file name is called first underscore node here, if you are able to see. Similarly, when I go to the setup file, so here the executable name is different, test node. Okay, so node, this is the executable name, this is the file name, okay, and this is the node name is different. Okay, here, like this also you can give, but which data you need to use, which information you need to use in this entry points console script, that properly you need to use. Okay, so both the examples are given here. Okay, this is one thing. So when I run this program, whether second day the same program has been run or not, I don't know. So because I need to show you what is this mean by the twist information, what is the meaning of this velocity information, especially for example message linear.x. Similarly, that information I would like to show. I'm just opening my command prompt terminal. Okay, I'll just reshare my screen. Yeah. So here I'll try to run. Okay, so let me see, that is in Docker. So I'm using two terminals here. Okay, I'm just running. Okay, this is what. So I hope so. If you just recall what I have just explained, so a robot will have x. If you take a 2D two-dimensional plot here, so this is x and this is y. This is exactly the center coordinate system. I hope so. No, the x is the value it is showing here, 5.44. Similarly, y is at 5.444. Okay, so that is what, maybe this is what 0, 0, the origin. And so when I start to push this data, so x will move at a velocity of 2.0. Okay, so linear velocity. Similarly with z, so z is z-axis. So with respect to, there is a angular velocity also. So based on this, so whatever the program I have created, definitely the robot will be able to create a circle. It can draw a circle. I'll just run the same program here. ROS run. Okay, so if I go back here, so the total bot can able to draw a circle. Okay, very simple. So now I can change the value here. You will come to know what is the usage of this Z value. I'll just make it as 2. Let me save this and then rerun again. So no need to build anything, because why you can avoid this Qualcomm build is, so when I try to build this particular node, I have used um, another function in called Qualcomm build called symlink install. Okay, so this will able to avoid us to rebuild again and again. So whenever we make any changes in the respective nodes. Okay, so this you can copy and you can try it at your respective machines. Okay, I'll just copy and paste it here. Okay, this will be useful. Okay, so now anyway, even if I do it, the same thing will happen. Okay, so because without running this, I would like to show. Okay, so now draw a circle. I'm running this node. Okay, let me go back to this turtle mode automatically. Since the angular velocity, the z-axis got changed, so means the more number of turning it is taking, so that's why it is making smaller circle. Okay, that's it. So here, when I print the information here, okay, so let me run ROS2. So you can see when I list the topics, okay, so what do you mean by topics? Already we have explained, you have got to know the information. I would like to even show you under QT graph as well. Okay, so this is what the current program is doing. So I'm sending this one node, this is turtle sim node, and this is the topic where the command velocity information it is sending through this node which I have created. Okay, so if you see here, this is what I'm interested in, this particular topic. So let me see. So what is this turtle command velocity is doing? Okay. Okay. If you see here, so when I try to open this, when I try to see the information about this particular topic, because I've listed the topics here, there are so many topics. So for me, the interest is with respect to only this turtle one command velocity. Okay, so I'm using this particular command to see the details. I'll just copy and paste it even in the chat bot. You can use it. Okay, so when I see this, it is showing that there is one publisher attached to it, there is one subscriber attached to its count. It is showing. Similarly, the type of messages it is receiving, what type of messages it is receiving. So geometry messages, geometry related information it is receiving. And so that's the reason why I have included in my program in the header. Okay, I've imported this twist module. Okay, so from geometry messages. Okay, geometry underscore messages dot message import twist. So that's why the reason why I have included here. How I came to know? So by running the demo program only I came to know. So this is what the information turtle node will able to receive. So when it is receiving, that means I need to send or push or publish the same type of message. Okay, so same type of message means what? So here I can just introspect what kind of messages it is going to send here. Okay, so let me show. Just a moment. missed the command. So this is what the command you can use to introspect what kind of messages this geometry messages is pushing. Okay, so that is what I would like to show, because based on that only I just in the second level of in my program, the second level of function when I created. So how I came to know about linear x, linear y, similarly angular z, that value. Okay, so you can use this direct this message, just copy and just I'll put it just a moment. Okay, so this is what the type of message it will want to when I call this twist method. So it is having three-dimensional information x, y, z, that to linear, similarly angular x, y, z. So with respect to my application here, I just need x value acceleration. Okay, similar in terms of forward and backward, and with respect to angular, I need only z. Okay, so because when I say robot moves x and y axis with respect to the angular, so angular with respect to x and y, it will not move because it is a wheeled mobile robot. If it was a drone, so definitely would have expect even x and angular x and y rotation also. Okay, so that's why I've taken only these two information in my code, and I've just just added in the publisher. Okay, so I'll just copy this and I'll just give you, because the reason why I have mentioned is to any node, to make that node as a publisher. Okay, I've just used only this particular function. Okay, so that I have created inside my constructor itself, and then using this I'm publishing the message, whatever the messages it is. So here in this example, especially the turtle node program is expecting velocity information. So that velocity information is of what type? This geometry messages, which is of twist data. So which is having both a linear as well as angular information, three-dimensional. Okay, so any questions? So I'll just copy this code and paste it here, and you can just use this particular code. Similarly, go back to subscriber. So I have even created a subscriber program. It is very, very simple compared to publisher. So here subscribe, what it will do, it will just receives the information, one node. Okay, so I can run this information as well. So here this circle in this draw circle information is node is sending x and z value. So similarly, so this is subscriber is receiving that information, correct? So the program what I have done here, so what is the displacement that is happening, whether it is linear or angular, the respective x and y value, nowhere it is printing here. For example, this is the node we initiated here. I have run this turtle sim node, correct? So it is just show the initial values of x and y before it starts its journey. The robot started to wander in its area. So, but now we can also see that. So exactly each and every instant point when it is moving, having a displacement. So even you can also have the data where the location of that particular robot on the domain. Okay, in that global space. Okay, so that is what the program is all about. This program is all about. So here, these first two lines are already are aware. And so what kind of information I'm trying to extract here? I'm trying to extract pose information. That's it. So position of the turtle bot, okay, on that 2D plane. That's it.
Sir, screen is not visible, sir.
Screen is not visible. Okay, sorry. Oh, there is some lag. Okay, I need to click on the G. Sorry, fine. Okay, sorry for that. So this is a very simple program, and yeah, when I open this, you can see here there is a displacement is happening. So even when I open this terminal window also, so when I ran this particular code, okay, so because turtle sim node, so it was initial values only, it was able to print. Okay, so now each time the displacement is happening, that that instantaneous updated value is not printing. Okay, so this is what one more node I have created, which is called as subscriber. Okay, so here I have used one more inbuilt function inside this, available inside this RCL Pi. Okay, so create subscription. Okay, so here also in the same manner, how are we sending the data while creating the publisher? The first thing was what type of information I need to receive there, what type of information I was supposed to send. So I have mentioned that. So a twist type of data, okay, which is having this linear and angular. Similarly, in the subscriber when I'm creating, so what type of information I need to receive? This is a pose. This is how I got to know. So once again, I have just introspected, okay, what type of information it is sending, okay, in the same manner. So similarly, from where I need to extract this information, so turtle.post. So this is what the topic. Okay, so and then I'm calling back this particular data. So this just to print this message on the screen. Okay, so there's only very simple program for the subscriber part. Just I'm receiving the information and just printing on the console. That's it. So I'll run this particular code also here. Just a moment. In the terminal. Okay, this is active. This is active. Here I'll just run. Okay, ROS2 robot controller. This is what post subscriber. Okay, so you can see the data is published. Okay, so based on the program, so each value, whenever the displacement is happening, based on that, I'm trying to print X and as well as Z value. That's it. Okay, X and Z value. Okay, so of course, for this robot to have this displacement, I have given linear X value and angular Z value. But when I'm trying to print this data during the subscription, I've just extracted Y, linear Y and linear X. That's position of that particular turtle bot on this 2D plane. That's it. Okay. So I hope you're getting this whole thought what I have done here. Okay. Let me see. Let me open RQT graph. What it will show. I'm just refreshing. If you see here, this is what. So draw circle is one program. Turtle Sim is already a demo program which is available. This is created by manually created, and this is the type of information it is sending. So from Turtle Sim, I can expect pose information. Okay. This also how I got when I ran that particular data, both turtle node and as well as turtle teleoperation key. So these two topics are already been created, and in order to extract the position data, I need to use this particular topic. So from there only, based on the introspecting the data, what it is pushing from the turtle sim node. So I was able to identify this the topic. I need to subscribe for the data to push it to my console. That's it. Okay. I hope this is clear. So here, the reason why I once again ran through this is I'm just killing all the node. So the reason is, so now I'm using today a program to create a simple subscriber node. Okay, so where I'll be using camera module of your own machine, so such that I can create a program where it will extract the data from the camera, and using the pre-trained model of YOLO, so I'll be able to detect the objects. Okay, so that is what the main purpose today. Okay, so let us start with this basic information. So how are we going ahead with our today's session? So coming back to this YOLO, I hope so. If you, most of you, the research personalities over here, if you have done your research in the field of computer vision or image processing, I'm directly using this YOLO because I'll be using this module also to include in my in the libraries when I try to use it in the ROS program also, and I'm creating the node. Okay, so this is what. So it's a simple object detection module they have created. So already the libraries are created, and as well as I'm directly using the pre-trained model here to use in my ROS environment. Okay, so this object detection, they have used various different types of formats. If you see here, we'll be having in PyTorch format also, and TensorFlow format. Okay, so you can see all these things. So TensorFlow Lite. So I'm using PyTorch module here. Okay, so it's a very simple program which I have created, and I'll explain line by line how to implement this as well. Okay, so before starting with this particular module, because outcome, what it is when I run this particular node, so which is acting as a subscriber. Okay, so only one program we are writing, which is a subscriber program, and we are also trying to develop. We are also using the available camera module. Okay, directly I'm installing that. I'll be using that as a publisher. Okay, so using that data. Hello.
Your screen is not sharing.
Screen is not shared. Is it shared now?
Yes, sir.
Yeah. Okay. So using this particular camera module, I'll be extracting the information, and I'll be using the pre-trained model of YOLO. Okay, so this is what a simple because I need to import this particular method, YOLO method, under this modules, and so we will be using this pre-trained model, whatever it may be. So I'll also show that also which I'm using, which version I'm using. Okay, and so that will able to detect the objects in the real time. Okay, that is what today we'll be doing. So for that, there are some background installations first we need to do. So what I will do first, I'll going to give you that information. Okay, I'll just send it in to your chatbot itself. I'll just create a file. Just hold a minute. There are steps you need to follow. Okay. So here versions are very, very important because I have tested this, and it has worked in my machines. If there are any such issues related to while you're executing the program, once you have complete the installation after completing your node creation in the ROS environment, if you're finding any issue, so I have just utilized ChatGPT, just copied and pasted that error to get it. Why? Because we are using ROS2, that too humble, and so currently the very popular ROS is Jessie. Okay, so that too they have created for 24.04 version. So that's why there is some issues with respect to deprecation in the installation, because when I install globally, so it will latest versions of the respective libraries will get installed. So that's why I have restricted, so certain versions of the respective libraries needs to be installed related to OpenCV, related to the YOLO. Okay, so and even pip also, and PyTorch. So all these modules when you're trying to install, so it should be specific. So based on that, I have tested in my system. Definitely, I hope it will also work in your respective systems. If you get any errors, so you just copy those errors and put it in ChatGPT. It will be able to help you out. That's the thing only. Okay, so I'm just pasting the step-by-step information here. Okay, in the chat box. So just copy this and then just put it into a Word document. Okay, so this will help you out in especially the basic installation. I request you to start with this installation immediately, and I'll just share my screen. And yeah, later I have created this document also. Suppose if you have created a Docker, because likewise currently I'm using Docker here in my screen, in my system, rather than to avoid this latency issues. Okay, so I'm just sharing my screen. Okay, so to avoid this, I have created this document. This document later I'll share post to this class. Okay, no need to be worried about it. So now, so very importantly, I'll just zoom in. Yeah. So very
Hello,
important.
sir.
Yeah.
Sir, I'm using Jassy, sir. So for that, can I change it to Jassy version in place of Humble?
Yes, see, there are a lot of differences even in the commands also when you're using Jassy. See, the basic operations related to node creations and all, it is similar. Only related to the versions, you need to take care. Okay, so first try to install without giving any explicit version number, any revision numbers. So try to install. If you get any error, so based on that, you just try to fetch. If you give that error in the ChatGPT, it will definitely suggest you the right versions for your Jassy installation, global installation. Okay, because most of the speakers were using ROS2 Humble itself, so that's why I have restricted my sessions only to this. And this is the actual basic foundation. If you have learned under Humble, I think most 98% of the commands are all similar. Okay, so but this Jassy Jalisco, especially they have used for especially industrial production or development itself. So you can directly use it, and they have created this Jassy only for 24 Ubuntu 24 LTS system. the next machine. Okay, so I'll just explain. So first you need to update, because I hope everybody have installed ROS Humble. I need no need to explain once again what you need to do it. And next step is, so this is what the build tool, Qualcomm build tool, if you remember. So this is what you need to install. Okay, so then this is right from installation of Humble, and this is what you need to update entire system. And following to that, once you install the Humble desktop, and you just need to source your script, this setup.bash script. So rather than explicitly opening using either gedit or any nano tool, so you can directly using this command, it automatically adds to the last line of your bash rc file. Okay, so next, very important, system tool. So what I have done, I have created a separate workspace. Okay, already have learned how to create a workspace. So if I go here, okay, you can see, let me see, you can zoom this. Yeah, I can zoom.
Sir,
Yeah,
after step 3, you have said log out, log in after this.
yes,
Like,
yes.
I have to like completely restart my PC or
Just
the
log out
terminal?
and log in. That's fine. That is what. Just log
Like
out
the
and
terminal, right?
yes, yes, yes. Or after installation, you can do in one step later.
Okay, sir.
Okay. So now I have separate workstation, sorry, workspace I have created here. So you can also create that, and I just change my directory to that. So it's in the similar manner. So you just create source folder manually using make directory command, a Linux command, and then run Qualcomm build with symlink install. Okay. So for example, Qualcomm build symlink install. Okay, if you do this, so automatically it will build. Okay, so this three more folders will get created. So that is what. Okay, so this is one thing. So these are the steps you need to follow, and then I'll go back to my instruction. Okay, so very importantly, this is what Python 3 Qualcomm Commons. So when you create any workspace, you need to install this. That is one thing. And so here I'm installing CV Bridge, okay, which is very, very important. So CV Bridge is a library or a module which helps. For example, I'm using OpenCV also. The data which I'm trying to get the information when I use OpenCV libraries, it is different. When I push the data back to the ROS environment, it is different. So this is why this CV Bridge library is very, very important to bridge between this OpenCV and as well as the ROS. Okay, so that is one thing. And so these are all the required related to the image libraries that you need to install. And you need to install this pip setup tools and wheel specific to this versions only, because I have tested in my system. So this is working for me. It is fine. So after installing this, if you are facing any issues, as I mentioned, put that error into the ChatGPT. It will suggest you the right version. Okay, so as suggested, so please log out and then log in post to this. And here, so NumberPython also you need to install. So this is the version. So it supports. Why? Because ROS2 Humble, it is not supporting the versions later than NumberPython more than 2.0. So that's why I have just deprecated. So if you just install as it is, so this is what you'll get an error. Okay, so there will be an error from the when it will read the image using the OpenCV libraries, and then it cannot be able to publish or convert. So that is what the error I have got. Okay, so just once it is done, you just verify using this Python command, get into the Python environment in the terminal itself, and then verify you should get this version whether it is installed properly or not. Okay, then install PyTorch. Okay, I have installed this using pip. Okay, so this is what. So if you just copy this and then paste it, you'll going to get the install along with the link I have just given here, and just check the version also. Okay, so last one is YOLO. Okay, so YOLO with vision libraries, because Ultralytics under this only YOLO libraries are available, including OpenCV Python. So this is the version I'm using here. So just install this. Okay, with this. Okay, so everything after this, this is what you need to create later. Okay, so you can once it is done. So there are only 6 steps. I think these 2 steps will take more time. especially. Installing PyTorch and then installing YOLO will take more time. I think more than 10 minutes it took for me. I think somebody has raised their hand. Any questions you can ask? Professor Babu sir, I think he has raised his hand. Any questions? Okay, so I request you to complete your installation. I think that is those are the steps I have just provided. Total 6 steps.
Sir, I have given your commands to the Chat GPT and Gemini and
Okay.
asked to convert into JASI format. So I'm trying to
Okay.
install through that.
Okay, great. Fine. So what I will do, I think if you have completed your installation, so let us try to, as I suggested, please I'll go back to the program now. So we'll start with installing, including all the libraries, and start to create the node. Okay. So step by step, we can follow each and every step here. Just a moment. I'll just create a file in the backend. Yeah. I'm just creating touch. So it got created. So as usual, the same procedure. So change it to executable format.
Sir, what is this executable format, sir? Why we need to do that?
See, very importantly, as I have given this answer even in the first session also. See, executable format, it will be because when you want to run Qualcomm build when you have done, right? So it will use executable format only rather than, see, because when you're trying to execute any code, whether it is C program or whatever the command, what command you're going to use usually. See, you have to use the respective executable command. For example, Python program, I'll be executing, I'll start with the Python 3. This is the command, and then file name, correct? File.py. So if I do this executable format, directly I can use this script, this dot / the same. Whatever the executable file I have, I can use it. Because Qualcomm build, when I used to build that, it needs to, the file should be in the executable format. So that's the reason why we need to convert that into executable format. That's it. Okay.
But
So when you
when
convert this into
reading this
executable format, directly you can use this period
Uh-huh.
dot operator and then / followed by the respective executable file name. It will run. It is just like when you download any software, it will be .exe format. You just click it and it starts to install in the same way. It is as simple as it is. Okay, so going back, so I'll just open this test node. Okay, and so let me use this. So very importantly, the basic thing is what you need to do. So you need to give the link or a path to your interpreter. So that's the first thing you need to do here, isn't it? So next is import RCL pi. See, this is what the auto suggestion that is I have mentioned. So go to the extension and then update, include all those stuff.
Sir, I have installed all those things. So what to do now?
Which one?
What you have given the
Extensions, right?
PDF files document. Yes,
Now,
sir.
once it is done, start to create a node.
Yeah, YOLO test node.py.
Yes,
Sir.
yes.
That,
Your test node, as it is, I did it here, no? So create that node. So that is why now we are writing the program. So we need to install one more direct camera library, camera module. Okay, so that will act as a publisher. So where it will extract the image information directly from the system camera, and then it will this particular will access a subscriber. What are the node I'm creating now? Okay, access a subscriber. Okay, so now to create a node, we have to use a class function. So for that, you already know. So use this. You import the node functionalities from RCL library. Okay, so node import node. Okay, so then define main function. So this is the basic skeleton I'm trying to give here. So name of your node. Okay, so you can put your name as YOLO node underscore node. You cannot use spaces here. So I think last time I tried, I got an error. Similarly, rcl_pi.shutdown. Okay, so these are the basic skeleton. Okay, so as we know, so now let us define a class. Okay, so in order to read the data from the image, and then so it needs to convert. So we are using CV bridge also. We need to convert all those stuff, isn't it? So that is what we need to do now. So we are creating a node, class. Okay, so called YOLO node. Okay, I'm inheriting the functionalities of the node from the RCL library, RCL pi library. Okay, so create a constructor. I hope everyone are following.
yes, sir. Following. Sir, can you share the code of those?
This is what I'm sharing the code.
Okay.
Step by step. Okay, once it is done, I'll copy and paste it. That's the reason I'm telling you to copy and paste it.
Okay, sir.
Okay, so just follow and update your code. So type it and update. Okay. Fine. So constructor, the first line will be super dot init, and then you have to give the name of your node. I'll be using the same name, YOLO. My name will be the same as the file name, test node. Okay, so here also I can give YOLO test node. Okay, let the names to be similar. Okay, so once this is done, so what we need to do, so here very importantly, so I need to bridge between ROS image and OpenCV image, because I need to use OpenCV libraries also here, very importantly. And then I need to create a model, YOLO model. So in order to create a YOLO model, I need to import that functionalities. Okay, so in the top programming itself, and very importantly, and we have to get some messages from the camera. So since we have to use sensor messages here as one of the modules, okay, in my headers itself, that is another important thing. And we have to import CV2. So these are the very important things I need to include in the program. So first thing is, so let me include the data, because when node is created, one is subscriber, another one is publisher. Publisher will be publishing some sort of messages. Okay, so here camera is sending some messages, which is in this format of sensor messages. Okay, so it is already available because I've already included auto completion here. MSGS sensor.message import image. Okay, from camera we are getting image data. Okay, so next is another thing is I need to use CV bridge functionality. So CV underscore bridge. Okay, so from this I am importing CV bridge module. Okay, that is another thing, and I have to import. I have to use CV2 libraries. Okay, so that's why I'm importing the CV2 libraries here, that module as well. And similarly, I need to import YOLO. Okay, so YOLO is available under this module. So Ultralytics. Okay, that is what I have showed you the website also. So import YOLO. Okay, so these are the prerequisites that you need to use in your program. I've just save this particular program. Now let us start with actual. We need to update our constructor, especially so because we need to create an attribute for everything. Yeah, so first attribute is, so I have imported CV bridge here. Let us create an attribute related to that CV bridge. Okay, so self dot, I'll just use a variable name called bridge. Okay, so CV bridge, so I'm using this functionality. So this is the class. Okay, I'm creating an instance here. Similarly, so this particularly, as I mentioned, this CV bridge will able to convert the ROS images into OpenCV images. That's it. Okay, so similarly, next is I need to use the module, and I'm creating another attribute called model. YOLO model I'm using. So directly I'm using YOLO. Okay, so this I have to use the available pre-trained model. Okay, so I'm using this pre-trained model of YOLO. Okay, so YOLO 11N. So based on the website I showed you, right? So 11N was the latest one. You can use this also. Okay, so this is one of the latest nano pre-trained model. So N stands for nano. So 11 is the version thing. Okay, so that is one thing. So after this, so we need to create a subscriber. Okay, so this node should work as a subscriber, and so whenever raw image is captured, so definitely, so that captured information needs to be received, and that image will be taken care by this subscriber node. That node only we are creating. So once we receive that information, which is an image information, then we need to process that image, right? So process that image here, what we are doing, we are trying to detect the object. Okay, so using YOLO pre-trained model. Okay, that too we are using nano pre-trained model. So that's why, so there won't be any lag while running. So my system is very very basic system. So i5, that too AMD processor with 8 GB RAM. So that is what. So I didn't find any lag when I ran this. Okay, so you can use. So that's the reason how powerful it is when I am using any hardware. When I built a real robot, so even Raspberry Pi with 4 GB RAM or 8 GB RAM will suffice. Okay, so it is more than sufficient, especially. And basic camera integration either through an USB port or through a camera port of the same Raspberry Pi camera. So you can read the data. So by using the camera module, inbuilt camera module library of our ROS, and then you can create this node. So it will work as a normal object detection in your robot. So once you detect the object, you can do a lot of other things. Actuation. Simple example. Assume that your interest is only identify a specific object. So because YOLO will do a generalized kind of classification, it will detect various objects. Okay, so here we can also identify only one certain object, and then we can track it. Okay, so this is the first step of identifying that object. Once you identify that object, so for example, if there is any that particular object is not static, if it is moving, so your robot can follow that object through the camera data. Okay, so that is one further application you can create with the help of a real robot also. Okay, so that is one thing. So let us create a subscriber node. So that's the reason why I have just help means give an example how to create a subscriber. Okay, so to create a subscriber, so what you can do, so we can use a simple command here only it is showing create underscore subscriber. It is an attribute. Okay, so what I am receiving an image here. Okay, so image is of the data type. So it is from the, I am receiving this from where it is showing here what type of message we are receiving, what type of from which topic I'm receiving here similarly, and which function I need to call back. So once I receive this information, what I have to do, so which function I need to call back, so all those things I need to give it. Okay, so
that screen is not visible.
that screen is not visible. Just a moment. Yeah, is it visible now? Yeah. Is it visible now? This is the one I'm talking. So this is what auto suggestion it will do. So when I click on this function, I hope this is visible now. I think
Yes,
so.
sir.
Yes, sir, it's visible.
Yeah, please. Fine. So this particular subscription function, it needs parameters. One is message type, what type of message, because I'm reading an image from the sensor from the camera, and then topic, from which topic I'm receiving this message. Okay, so I'm receiving a message from a topic called image_raw. Okay, this is a topic. Okay, so similarly, I have to create a callback function. Okay, so I have not yet created callback function. Let us create the callback function and then update this particular line. Okay, so here to create a callback function, once again in the same way, so I'm using just creating image CB as a callback function, or you can directly write image_callback. Okay, so self, and then one more parameter for this function is message. Okay, so after this, so create a variable. So once you call back this function, you need to load an image into a frame, isn't it? So here I'm using CV bridge function. Okay, so directly I'm reading the data from the camera, and then I'm uploading here. Okay, so self dot, because I already created the attribute inside my constructor, CV self dot bridge dot image message to CV2. Okay, so this is what the method I'm using here. Okay, so I'm using it needs what type of message I'm receiving, that is what, and then to which format I need to convert. So desired encoding methodology I need to use. So message comma, I'm converting BGR 8-bit format. Okay, so this is what the conversion, so this is what the bridging will do. Okay, I'm storing the results. Okay, so now I need to use, once I read the frame of the camera, already I have an image now. So from that image, I need to do the detection. So for detection, definitely I can use the model. Already I have created an attribute here, self.model. I'll be using this model only. I'll be storing that result, storing the data into another variable called results. Okay, so it is very simple. Like if you have done any object detection using OpenCV, any such projects or research, so I hope you can able to follow what I'm telling now. Okay, so self.model. Okay, so this is where I'm storing. I'm trying to that is a YOLO module is got stored in this particular attribute. So you can use frame. Okay, and then so I just need only one frame. Okay, this is a color image, so therefore I'll be taking the first frame. Okay, it's an RGB format, so it's a BGR format, blue, green, red. So I'm taking only one frame. Okay, so now once it is done, what is next here? So very importantly, we need to identify that. Correct? So we need to identify that particular object. Okay, once it means that those objects which has been identified with this particular module, it will be stored here in the variable called results. So this results will have the data. So where it will be having just a coordinate information, like it is just like I'll show you when I try to extract this information how it would be. So I'll be trying to run this information here. It will be a list of information, and list means data structure list format it will be using. So I'll be using a for loop to read each and every data, how many objects that has been received, detected. So using this results dot boxes. So this is the functionality I'm using. Okay, so I'll be this information I can extract, I can put it into format to just to draw a rectangle box. So using computer vision commands. Okay, so I'm just running through the entire list here. Okay, so in this data I'm trying to extract, I'm reading that into the box. So I'm just taking the coordinates xy. So when I try to write or draw any bounding box on top of it, so I need to have two data, origin point and the uh, another extreme point, so diagonal opposite point. Okay, so I'll just call x1 y1 is the origin point. Similarly, x2 y2 will be diagonal opposite point. Okay, so using these 2 points only I can draw a bounding box onto the detected image which can imposed onto the red frame. Okay, so whichever the frame we have already read here inside this function, so we can directly write that. Okay, so create that. So now I'm just doing just conversion here. So which of the data I'm trying to map this data, I'm trying to extract this information. Okay, so box has stored all the data. Okay, so like this xy xy. So once again at the first information, so in the list. Okay, so this will be extracted and it will be stored here. So one of the beauty of the Python is, so this is what, so multiple assignments can happen here. Okay, so both in RHS and LHS. So now what we will do, we'll try to create a rectangle frame. So I'm using CV2 library here. So rectangle. Okay, and then so where I have to draw the rectangle onto the frame, right? So frame means I need to have a coordinates 0.1 and 0.2. That is what it is suggesting here. Okay, so it should be in this parenthesis itself, x1 comma y1. Then 0.2 will be x2 comma y2. So this is where we have stored our points. Okay, so after this, so we need to put what kind of color box we need to put. Okay, so we know it is RGB format. So let us give the color. So 0 is black, so 255 and 0. Okay, so RGB. So G is high now, so G frame is high. So that is what I'm putting. So thickness it is asking, I'll just put to 2 points. Okay, so once it is done, so I'm reading the for. So inside this for loop, so whatever the detection that has been made in the single frame for each and every object, so we are trying to put a rectangle box here. That's it, bounding box. So after that, so we need to just display. So using I am show. So inside this CV2, so I'm just using this. The system is lagging. Okay, so try to update this. Just a moment, I'll just stop sharing. Yeah, sorry. Sorry, I just rejoined. My system got restarted. Okay, I think just a moment. I'll share the program. I think you can just update this and you can just run this. If you just find any errors, please let me know. Okay, just a moment. Okay, so please copy this and check. Let me set up my system. Once it got restarted, I need to restart my Docker as well. Just a moment. I've shared the program, so please request you to try this.
Sir, this is for YOLO test node.py, right?
Yes, yes.
And what about YOLO node.py?
Both are same. Both are same.
Okay.
No problem. Just I've changed the name. That's it. The functionality, everything is same. Only the name is changed. That's it.
Okay. I thought in that also some code exists.
No, no,
Okay.
no.
Okay, sir.
Just to avoid this only, I just created my Docker, but still also I got the same problem. It's okay. Now it got resolved.
Sir, in my VS Code, Ultralytics got something error, sir. So do I need to include that product?
No, we have not updated all your in the package. Sorry, we have setup.py, right? That needs to be updated, right?
No, sir. This Ultralytics from Ultralytics import YOLO.
Yeah. Ultralytics import YOLO. You got the error.
Yeah, Ultralytics got error, sir. Something bottom lines.
Okay. Let me check.
Zigzag. Do you need to install any package of in VS Code?
No, we already installed Ultralytics, which I shared earlier. I think my channel got disappeared. Just a moment. See, step 6, you have installed Ultralytics 8.0.196, which I have shared in the document. The previous chat box, in the chat box previously I've shared that information. Have you missed it? To install that?
Yes, sir. I have installed that.
Then it should not show that error.
Okay, I will try to install again, sir.
Yeah, please try to install. Okay, let me share my screen. Once again, I'll run this before we start.
Sir, excuse me, sir. Like
Yeah.
regarding step 6, sir, like there is slash coming after user. So should I, whether I have to remove that slash?
No. You have to include everything. You have to include that slash. Everything. Copy as it is and then put it in the terminal.
Okay, thank you.
Sir,
Yeah.
I tried the code. It's not running right now on my system.
No, code will not run because there is a procedure. So this just to copy and paste it in your system. I'll teach you how to run that code. Okay.
And
so
about the
because we
Docker,
have not
sir,
updated, because we have just created a node. We have not updated the setup file, and we have to build callcon. So post that only we need to run that. Okay.
About the Docker system, if I want to implement it on my computer, how should I do it?
First you need to install Docker and then create ROS.
I got the Docker.
You got the Docker
Yes.
already installed?
Yes. It was in the prerequisite item to install Docker in our system.
Where in the information which I shared?
No, not this. It was shared before the FDP got started.
No, I have shared, sir, because that is required for autonomous navigation in the
Oh,
for
is it?
the
Okay, okay,
Saturday session. Huh.
okay. No, I didn't understand your question. If you have installed already, ROS should be there, no, inside the Docker.
Like, do I need to set up a Docker in a specific way so that the ROS
No.
because I download everything separate way, and I haven't used Docker before. I do not know. I just heard the name Docker, that there is some system like this, but I don't know what it does or what it helps
See, it
helps
is
with.
just like a container. Docker is just like a container, okay? And see, and whatever you create, it like whether you remember, you will create your own virtual environments. So whenever you work on Python projects, isn't it? So in the same
Yes.
Docker also, it is just like a container, and whatever the applications you install, it just creates this image inside that. It runs that image like how you insert a CD into the CD drive, and similarly how you create a bootable disk in the same format, it runs the applications. Okay, so inside a Docker, n number of applications you can run without any.
Like when I was installing Docker, and because I know that PyTorch and all those like require CUDA environment to run those setup, I asked ChatGPT, like, should I install CUDA on my Linux on my Ubuntu machine? It said if you are installing Docker, you don't need to get separate CUDA environment.
No need to, because I have tried. It doesn't require CUDA environment. It's not at all required. Suppose only if you.
Because sometimes PyTorch calculation goes
If
heavy,
you are yes,
and
if
if
you are
it
doing
goes
any,
on the CPU, it will crash.
yes, machine learning. If you are doing, then CUDA environment is required. Even for OpenCV also, I have included that. But simple for ROS, I have not included that CUDA environment. I have not installed here.
And sir, I want to ask one thing.
Mhm.
This face tracking object detection thing we are doing,
Mhm.
I have a ESP32 cam module.
Okay.
Can I get a node, like an image processing node in my ESP32 and transmit the live data wirelessly through a network system?
Live data of image, right?
So like I have a ESP32 cam
Correct.
module. So it's a small
Cam module,
ESP32 which has a camera.
ESP32 with camera, isn't it?
Yes.
Okay.
So if like I make a image capturing or a video capturing node and put it on the ESP32, it will send like live data to my object detection, and it can show me the live image object detection
No,
thing on my
see,
PC.
ESP runs on simple microcontroller. Okay, so
Yes.
memory is very limited. You cannot, I think, create node or a ROS environment inside ESP32. That is the main problem. Okay, so for that, there is a special micro ROS is available. Okay, so I have not worked on micro ROS as of now to start. The only thing is, see, you can transmit an image wirelessly. Of course, ROS communications are there. Suppose if you have a server, it can act as a client. Your ESP can act as a client. If you have a server, it can be a Raspberry Pi or your normal system where you can connect wirelessly through Wi-Fi. Okay, so you can try to read the data from the ESP32 module itself. So that image data only. So if you have a memory, means anyhow in your server system, it will be there will be a memory. So you can install and you can create a node and then do whatever the information you can do. In the same way, so when you're trying to create a robot operations also, one will act as a client, another one act as a server. Okay, so master and then how your child it works like in the same manner. Okay. So, but whatever the hardware you use, it should be able to have that capability to install at least, because ROS is not a standalone operating system. It runs on another operating system.
Okay, sir. And one more question. From a long time, I'm trying to learn ROS, but because it's so complex in nature, like I have to change so many files just to run one code. Like I am not able to find a specific way to learn like step by step, because after few like 3-4 steps I get confused like where I have to go and change again. So what should I do about it?
No, that's the reason why you're attending these kind of trainings. That is one thing. So there are
Yes, sir.
lot of even free videos also. Even if you go to Coursera, you'll get a lot of material. I have few popular. I have followed few popular tutorials. I'll share it. Okay, so you can follow that. It's available on YouTube itself. And it is not that I mean, there are no so much of videos available. A few channels, very less than it is not more than 10 or 12. Okay, so but there are some good resources available on YouTube also, and there are some courses. I follow Coursera courses, so there I found few good courses related to ROS.
Can you suggest some base like ROS course which I can like go through, because right now I am doing one course on Coursera that is open CV type course. Like they teach me the whole open CV and PIL library.
Okay.
So I'm doing that right now for image processing things.
Okay, see, image processing, best thing is go with OpenCV only. OpenCV is very, very handy. Lot of resources available. So even no need to buy courses. A lot of resources are available. Even if you go to the tutorial inside OpenCV also, there are free tutorials available inside opencv.org.
Okay, sir. Okay, sir.
Okay. Fine. Okay, let us go. Come back to this. I think time is running. It's already 9. So I'll take another 15 minutes. We'll just wind it off. Okay, so Docker. I'll just share my screen.
Sir, I have just question on Docker, sir.
Yes.
So, in my Jassy, in my Ubuntu 24.0, in that version, I have installed Dockers. So, will this Docker setup will be compatible with that what we are going to provide?
See, I am running Docker is another container. You can install anywhere, whichever the software means OS you are using. So I'm using, see, since my machine was incompatible with respect to the memory and processing speed, it's quite old. So that's why what I did, rather than using virtual machine, which was eating more of my operations computation capability, what I did, I just upgraded to Docker. So it was running very, very smooth. So there was no lag at all in the system. Okay.
So my doubt is, ma'am said to install in 22.0, right? Ubuntu. So I have installed in 24.0. So will it be same for this also?
Yes, same for them. See, in my 24 system, I'll share my screen just a moment. Share. So this is my 24.2 installation.
Okay.
So here only I have installed my Docker. See, this is the Docker. Let me show you. I'll just exit. So this I've installed my Docker, and you can see this is the image I'm running. See, ROS Humble desktop. Since it is not compatible with 24.04, so I have created Docker. Inside the Docker, we can use this image as an image. So inside this only, I'm creating workspace, projects, everything. It is not hampering any of my external thing. Of course, when I'm trying to access any root script files, bash.rc, so separate bash will also get created inside this. And if you see any modules I have installed here, so for example, extensions. So all these extensions got installed inside that container itself. You can see container ROS Humble. So in order to detect when you install Docker, also when you try to access any files which you create inside the Docker, what you need to do, very important thing is you need to install this Docker module also as an extension. Here, Microsoft. This also you need to install. So once you install this, so automatically you can detect the Docker images. Okay, so to detect the Docker images, you can go to command palette. So here you can see show containers. It will show whichever the containers you have. Okay, images. See, this is the two images I have created here. So one is the running container image. That is what dev container. So you have to load it. So when you go to here, you can just whatever the containers which are active. So if I'm showing here based on this Docker PS. So this is the container active, and this is the image that is running inside this. So you can just click on that. Go here attach the active container, it is asking ROS2 humble. ROS2 humble already have installed inside that Docker. Okay, so click this, automatically it will go here. So directly you go to file. So if you have created any workspace, so you can identify I have created 2 workspace here. Okay, so this is what I'm loading. Okay, I'm using it. Okay, so you can also see the same inside this. So I am inside the root. This is not in the root, so I'm inside the root level. So if I just list, I can see there are 2 workspace. So when you install the ROS inside the Docker, if you want, I can share you the installation guidelines also. Automatically it will install and it will create this basic workspace initially. Okay, this I have created explicitly. So now I'm running the code now. Okay, so now already this code has been created. Last thing, image show frame, and then you have to use this wait key. So wait key is just that you have to refresh your frame. So if you have worked on computer vision libraries, so automatically, it's when you say it's a video is nothing but a sequence of frames, right? So some camera reads at 30 FPS, some it reads at 60 FPS, or standard is 24 FPS, frames per second. So your frames needs to be refreshed. So that's why I'm using this wait key. Okay. So if I use escape button, or if I click escape button, automatically it will stop. Means it is just like hard stop. I can do it. So this is what the code we just created. We have created a subscription node, and once this module got created, this function got created, I need to complete this subscription command function. So by calling this function, that is image_cb. So this is the buffer space. So where 10 such calls can accommodate in the buffer. That is what. So this can be any number. Let it be less than 50. That is what. Or based on your system performance as well. Okay, so now what I will do, I have updated this code, so I'll just explain you that later. Okay, I just commented this particular part, this is the updated code. That's the reason I have created separately. And then here, create the object, and then you have to spin this. The reason, why we need to spin this is the node should be always, it should not exit once you one time after execution, you continuously execute this particular node. So that's the reason we will use this spin function inside, which is available inside the RCL file. So post to this, what you need to do, you need to install, you need to calcon build. Do that. Do not forget that, very importantly. So I'll just go to this ROS2 object detection folder. So build calcon. While you're building, use symlink install. Okay, so it will build. Okay, so it successfully built this particular thing. So if you found any error, so here you will not get any error with respect to any installations. During execution, you may get error. So it will build successfully. Okay, if there is any version issues, okay, so you can solve that. Give that error into ChatGPT. This is what the instructions I followed during the installation to run this particular program. You'll get the entire updated versions itself. That is one thing. So one more information I need to give. So now your node is set to run, but only thing is you need to install another camera module. That is very, very important. I'll share that also. That code, it's very simple. Just a moment. Somewhere I just captured it. Yeah, so there are 2 steps you need to follow. Okay, so I'm just copying this 2 commands you need to run. I'm just pasting in your chat box itself. Just copy this. Okay, so very first thing is, I'm just resharing my screen just to explain you. Okay. So you have to install this camera driver. This is version 4 L2. Okay, this is what the command you need to follow. Okay, so to read the camera, the hardware which is available in your system, that is the first thing. And once you install this, automatically you can find this node available. Okay, you can find this node. Okay, this is the only one instruction you need to follow to install the camera driver. Okay, so now let me run the code. Okay, so first I'll run the camera because I need to publish the data. Then I can receive the information, I can run the subscriber later. Okay, so let me run. So ROS2 run, already have built. I've installed my camera driver also. Okay, so let me run this. So it is showing already it is installed. So I just double 2 times I'm clicking the tab. It is showing. So this is V2 camera node. This is what I need to run. Sorry, V4 L2 camera node. That is what we need to run. Okay. See, once I ran this, automatically my camera got active. Physical camera in the laptop got active. Okay, so it is sending the information. There are some errors, warnings. No need to be worried. Just neglect that. So what I will do next, I'll run my YOLO node which got created, which I have created. So first I need to come to root. Okay. Okay. So now let me run. Already have built the package. Okay, so ROS2 run. So I have given a name. My object is this is the package I have created. Okay, that's why I told you to create separate workspace and then package. This is the first day's information I have created. So inside this already YOLO node got created. So just run this. Okay. Yeah, see, I'm seeing this. Okay, sorry, one thing I'll just stop. I've not updated the code. Just a moment. It should not show all the things. Yeah. See here, it is trying to detect the object. I'm sitting here. So it is detecting the bottle as well. Okay, if I show my mobile phone, it is detecting, but it is not giving what kind of object it is. So that is what the program. Okay, so later after this, I've just updated what are the program I've showed. I'll show you the updated one, and here you can see at the rate of FPS 30 FPS, it is showing it is detected object. It is displaying here as well. Okay, so that you can see it here. I'll just stop this node, kill this node. I'll go back to the program. Okay, so what I did, so here another updations, what I'm doing here, I just need to identify the object also, whichever I'm showing. Okay, that is one thing. So that's what I'm trying to create an ID here. Okay, so this I have taken from online itself. Okay, so already we have identified the objects using this model, pre-trained model, YOLO model. So using this, I'm creating an ID, because with the help of this ID only, I can create a label. Okay, so this will help us to create the label which is stored here. Okay, so box.classes, which holds the labels of all the, okay, so object, it got detected. So now using this model.names, because model is got trained to identify the objects, I need to extract the names as well. With the help of this ID, I can extract the names of this model. I'm storing it another label, variable called label here. Okay, so this is available in this particular list. Okay, so next is, first I need to extract in the form of text. Okay, so that's why I'm trying to extract here in the form of strings. So that's why I'm using the formatting strings. So it got converted into strings. I'm just storing this. So these are the 3 lines that extra you need to add into your code. Okay, so next very important thing is, so where I need to display this. Anyhow, we have created a rectangular bounding box for the detected object. So this already we have done in the previous code itself. Now I need to put the text, whatever the labels have been detected from this model, the YOLO model. So I'm using this inbuilt OpenCV library inbuilt command. Okay, so CV2 put text. Okay, so where I have to put in the frame only. So this is the frame which I have read earlier, and then so I have to put the text, because text is where I have stored the actual object detected names. Okay, and then where I have to put in the location. Okay, somewhere on the location of the bounding box, x1 y1 minus 10. Okay, this is the location where I'm putting the origin location. okay, of the text, and then font I need to put. Okay, so when you try to update this, you'll get the data. Okay, so here this is the function where you can see it needs to give the image string. Okay, font face, font scale, everything I need to give. So CV2 font, and then this is what the size of the font. Okay, and then this is the color of the font. Okay, so let me give you the command. Okay, this is what, see here, image matrix, then the string, the font face, means this is what actually simplex, that is what I'm using, font scale, size of the font, and the color and the thickness. Okay, that is what thickness of the font I've used 2. Okay, this is what, so I'm just saving this particular code, and then I'm running now. Okay, there is no other changes. What I will do, I'll just copy this entire code again. So updated code this is. Okay, so yeah, I can have a lot of other activities where you can also try it out later. I'll give you some assignments, you can try it. Okay, so this updated code, I'm just putting it in the chat box. So now let me run this particular program. Already camera is reading. I'll just kill this node. Once again, I'm running this camera node. So let me run my YOLO node. Yeah, see now, bottle, it is identifying. I don't know what other objects I have. Mouse, let me see whether it will detect mouse or not. No, it is detecting as person. It is detecting it as clock. A cell phone it is detecting. Maybe I'll put like this. Yeah. I hope. So I think there is very less lag compared to this. And you can also reduce the frame rate when you're trying to use it in the real robot. Okay, so let me kill this node, both the nodes. Okay, so yeah, so I just forgot to show you the graph. Just a minute. Yeah, so this is the graph where you can see. So this is the camera node, which is already we have installed the driver. So where we are getting the image data, which is of raw image, and that is what we have included. We have subscribed to this topic. This is the YOLO node which got created. Okay, so I hope we have got the clarity even through these topics as well. Okay, so let me close this. By now you can try out various things, and very simple, whatever the things you are doing, you can do it here itself, in this, especially in this image callback function. So because this constructor, whatever we are doing, we have created the attributes, that's it. And even I have tried this another version, older version also. You can just use this as well. Okay, so it will run perfectly. Okay, so let me run this camera mode. Yeah, this is quite faster. I think the response is quite faster compared to that. Okay, you can use this. See, once you have tried to use this, if you have observed, if everything goes well and installation, everything is fine, you can see here automatically these points also got created here. So this is the there's a point, the pre-trained module points, that is what, whichever the objects that needs to be identified. So that is what the files that are also got created here. So now going back, so I think already we have crossed 20 minutes extra. The only thing is you can try to add more activities here. For example, your interest is only to identify, for example, I've showed the bottle. Okay, so now assume that your robot needs to track this particular bottle, water bottle, and you can restrict your this function, this only function. So assuming that label is identified as a bottle, okay, then so only that bottle needs to be tracked remaining bounding boxes you need not to display. Okay, so you can update that particular code. For example, here, whatever the objects we have detected through this results, so we are trying to create that object is already been captured, means using the bounding box we are marking. Okay, instead you restrict yourself to only specific object. Assume that your interest only to identify the bottles, only that bottles needs to be bounded box, and then label it. That's it. In the same way, assume that if I have assume that you are doing a factory automation, or assume that you are put a robot, and in a car, assume that you want to identify the pedestrians, how many pedestrians are crossing a lane. Okay, so you can also count the number of pedestrians or number of people available in front of the camera, such that you can put that count. So likewise, you can update the same code by just identify the respective objects through this pre-trained model, YOLO model. Okay, so that is those are the upgradations you can do it. Okay, the only thing is missing here, since it is online, so physical robot I couldn't show it to you. So where you can using this pre-trained model, not only the predefined objects or trained objects, you can also train your custom images as well. Okay, using this YOLO net. So if you just go through the object detection website from this Ultralytics, so you can also, means that is what the transfer learning technique that will we usually follow. There's a standard name that we usually follow in industry. So already pre-trained model we can use to train your own custom data set. Okay, so even TensorFlow model, AI model can also be trained using this transfer learning technique, and based on your own restricted, your own interest objects can be detected. Okay, for your own application. Okay, so I hope this session was quite informative, and so try this. So very importantly, so when you're trying to, because rather than using a simulation tool, so if you have a real robot, okay, for example, if you're running a robot and through using a serial communication, just trying to, if you have a driver board, motor driver board, which can take the data from the serial communication port, and using the laptop only, the turtle bot is the best example. So you can just actuate the motors, and with the camera of laptops itself, so you can identify the object and you can do a lot of things. So this is what the basic foundation that I was able to transfer during this 1.5 hours duration. So where you can create a node in the form of subscription. Why it should be in a manner where it will try to extract the information from the YOLO, and then from the hardware camera, and then it is detecting the object using the pre-trained model. Okay, so yeah, over to you, all the participants. If you have any questions, you can just I can just try to answer.
Sir, excuse me.
Yes, yes, tell me, sir.
Sir, regarding that camera thing, so suppose I'm using a desktop and I'm using an external camera, right?
Yes.
So with the desktop, so the same code works, the driver installation, or will it differ with respect to?
See, when you're trying to use, what it will do. Basically, assume that if you have a 2 camera, you'll get an option. So there will be a device ID will be there when you're trying to read the data. Okay, so the installed camera driver will be always implicitly, it will be always redirected to device 0 ID. Okay, if you are using external camera, so I think that device ID needs to be changed. That's it.
Okay. Okay, sir. Thank you.
Yeah. Any other questions?
So we are using now Python, right?
Correct.
So I have heard that if you use something like C++, it will be the communication will be faster.
Correct.
So is that true?
Definitely, sir. It is true. See, there are a lot of discussions, even especially if I take an example of open computer vision libraries. So they tell that performance, suppose if you develop any application using C++ and even Python also, the operations time, everything works almost same. Okay, that is what the OpenCV libraries they have built. But when you come to the actual Python, you know, right, Python, how they have built the font for, if you go to the version of Python 2, 2 version. So it built, means the Python script has been created, basic library is created using C language itself. Correct? So that's why, so when you run the code, so C has a compiler, Python runs with the help of an interpreter. Okay, so backend, it should get converted into C language, and then it will convert into machine code. It takes time. So C++ definitely it will not have that latency, especially because of this conversion. So, but when you start your learning journey, so Python is very, very handy, easy. You know the advantages of Python over other programming languages. Concern to hardware, because when you come to C++, you have to know how to manage the memory. Memory management is one of the biggest tasks, especially with respect to the hardware devices when you are using. So you should be well versed with the concepts of pointers. Okay, when you're trying to use C++. Okay, and you have a vast library also compared to, it is not that much easy to understand also. That's why it is quite complex when you're trying to, of course, when you're a developer, definitely you kickstart your learning journey with Python, and then drastically, gradually change it to C++ development. There also classes and objects are very, very important. So because the language as in which it is quite different compared to Python and C++, definition, syntax, everything is different.
Yes, I got it, sir. So in the middle of the session, you told that some tutorials are available. So can you share those tutorials?
Definitely, I'll
I'll
share it. It is not in handy now. I'll fetch it, the link, and share it in the group itself. Is it okay? Give me time
Yeah.
tomorrow till 12. I'll share it.
Yeah, it is okay, sir. Sir, actually, now I mean, I have built my own, means I won't build my own URDF file and I have added some camera plugins, sir. So now
Okay.
I want to go with this detection. So
Mhm.
this same code can be used to plug in those in the ROS2 in my project. Can I use this code, sir?
In the simulation, either Gazebo or any other simulation tool, that is what you are
Yes,
talking
yes,
about.
in the gazebo.
Definitely, same tool, same code can be used.
Okay, okay. Oh,
I tried actually to show, it was taking too much time in the system, so that's why I couldn't do it. I can share you the example. I just tried to show the demo. It was hanging, so that's why I don't wanted to show.
okay.
Same code. There is no change in the functionality at all. Instead of real hardware, so what you're trying to do, for example, if you're using a gazebo environment, there will be a camera available. So there will be a separate camera driver or a library function to read the data from the virtual camera. So you'll install that, you read the data, same thing, same image, raw image data can be fed to this particular code. It will work.
Okay, okay. Yeah, got it, sir. So related to ROS2, anything available, please share that also, sir, if possible.
Definitely.
Yeah, it will be more helpful, sir. Thank you, sir.
Sir, can you share how to install a Docker, sir?
Okay, so I think I have half documentation I have done.
Okay.
Just a moment, if it is there. Yeah, it is there. I have created Docker installation. I'll share it this time. Shall I copy it and paste it here itself? Is it okay?
Sir, is it possible to share in WhatsApp, sir?
In the group, I'll share it. I've created a
Yes,
documentation for this. I'll share it.
thank you so much, sir.
Okay. Ma'am Arpita, over to you. I hope I've utilized half an hour more.
It's okay, sir. The session was very, very informative session. Even I have not worked on this. I worked only on mapping, localization, and navigation using only a single LiDAR. I have not worked with the fusion of LiDAR and camera. Actually, it was a very informative session, sir. Thank you, sir, for explaining the step-by-step like object detection in a roster. Thank you so much, sir.
Thank you. Thank you. Yeah. So
participants any feedback for this, because sir's session is today's last session of Raghunandhan, sir. Would you like to give any feedback? It's open.
Ma'am, really it's very good, but if you get the same procedure as a what do you say as a document, then it will be more fine to practice.
Madam, really, it was a really wonderful session. We enjoyed, and really happy to practice hands-on session on ROS. Basically, yeah, definitely. I'm looking forward if offline such kind of program would be there. Really, it will be interesting and more enjoyable. Basically, yeah.
Thank you, sir. Sure, we'll actually keeping that only in mind. I have written a proposal for this ROS2 session because when I was doing my research work in 2018, there was no like resources available. If you just think now also, if you search, there won't be any much resources available. Like either you have to like pay, you have to subscribe for some courses by paying. So, but in YouTube's and all, there are no tutorials were available. So, keeping that in mind and to make the like, especially even for our resource persons also, we didn't get any resource person from the like colleges or universities. So we have to tap industry persons only, and also there were no much work in India like with respect to ROS2 or ROS, or it might be any robotics as well. So keeping that in mind only, we have written the proposal and we have organized it. And we especially don't wanted to the session to be a like a theoretical session. We wanted a hands-on session because I know the pain, because that time during 2017, even to fix a simple sourcing this thing, when we build using in ROS1 Catkin make, in order to know that I need to source the terminal, I would have taken 3 days to know that, because that time there were no like chatbots and everything. So that was the hard thing that time. So hope this session at least reaches those who are in the journey.
Yes, madam. Really interesting, and really, we are thankful. You are providing immediately that videos, so that pace is quite good. But anyway, because of our slow pace now, we sometimes we lag. But when we go back and again rewind these videos, now again we'll pick up. That's a really good practice basically, and that's how we are able to match again, and we are able to practice more basically. Thank you very much, madam. Thank you, sir.
Sure,
Thank you
sir.
very much.
We'll share everything. But the only thing is you need to practice from your end, because this is the domain where you will be learning the ROS2 by fixing the errors. Isn't that Raghunandhan, sir?
True, ma'am. Because see, when we start to jump into actual implementation part, you'll come to know various problems. Why? Because even now also, most of you have tried to install, you stuck in when you try to execute the program. So that's why I told. So in my system, it worked. Maybe there may be some challenges also you face when you start to install and then start to do it. So that's why actually today for this session only, I just created this particular separate activity. It almost took 2.5 hours for me to debug the errors. Okay, so because latest OS, old ROS, so there was some compatibility issue. So that's why when you try to learn things, right, so you try to use the latest upgraded version control. But one thing is, so nowadays even in ROS also there are a lot of good resources are also available online. So for free of cost also, and also paid courses are also available. But only thing is, so to have a better outcome, you should have a better hands-on on the hardware side. Okay, so if you master the commands and all, it is very easy. Okay, remaining part is because I didn't go directly into the detailed basic versions of how to do in Python program, because assuming that everybody are aware of this programming language, so as I started with classes implementation itself, because even I have tried to teach students as well. So students have already cleared their papers in the programming languages. So when we start to ask the questions, and because since it is a hands-on session only, the basic knowledge related to programming is very, very important. Otherwise, students will also get bored if they are not started to understand. Okay, this is what the gap actually. Even they have cleared the paper, they have lack of practices, especially. So when they start to build any projects, any researches, okay, that is why only it will be on the papers rather than the physical outcome in the form of the hardware or the actual output we need to have. Okay, that is what it is, where it is lagging. So that's why practice is more important in this domain, especially.
Yes, sir. At the beginning, it's very painful. Doing the mistakes and learning, it is true, sir. And also, I really appreciate, sir. You have patiently, cool and calmly, you have explained very detailedly, sir. I really appreciate that one. You have taken enough time to explain, sir. You are focused on learning to teach. Yeah, that was very nice, sir. One of the best lecture.
Thank you very much. Thank you very much.
Yeah.
Hi Raghu. Nice to listen to your lecture after a very long time. This is Sanjay.
Hi Sanjay, how are you?
Good man. Good.
Thank you.
Very nice content that we have you have covered. And thanks, you had already covered couple of sessions for us for TurtleBot and other things. We were getting stuck in between to recalibrate those things. So we got a lot of insights into ROS and how to program, troubleshooting, and other things. Thanks, Raghu. Thanks, Madam Ji.
Thank you. Thank you very much. Nice to see you in the session. Both the sessions.
Thanks.
Thank you, Raghunandhan sir, for your valuable insights and guiding us to learn this concept. Thank you very much, sir.
Thank you, ma'am. Thank you very much, ma'am. Thank you. Yeah. Fine, ma'am. I think good to conclude, I hope.
Thank you, sir.
Sure. Good night, everyone. Have a nice day. Okay, so I've shared the installation guide as requested. Even today's sessions also step-by-step installation, and then program is also there with the description. Okay, so both the variants with Docker, without Docker, everything is shared in the PDF format. It is shared in the WhatsApp group itself. So try out. Okay, and yeah, so anyhow, contact is available, so you can just ping me if there is anything.
Sir, just 1 minute, sir. Sir, 1 minute, sir. Raghunath, sir.
Yes.
Raghunath,
Yes,
sir,
sir.
1 minute. Sir, actually, we are planning. Our university is planning to start a center of excellence for robotics. So,
Okay.
may I contact you, sir, for resources and the infrastructure to you?
Definitely, sir. Definitely, sir.
Thank you, sir. Thank you, sir. Thank you.
Thank you very much. Yeah.
Sir, also share this ROS2 tutorials which are available, sir.
Sir, sorry, ROS2?
You said ROS2 tutorials are available.
Yeah, that I will share, sir. I need to fetch it. Videos and all, I'll share it with you.
Yeah.
I'll share the latest one only. Jasi Jalisco, that ROS2 tutorials only, I'll share it.
Oh, okay, sir. Yeah, thank you, sir. Thank you so much, sir.
Okay, fine. Fine, ma'am. Good night, everyone. Thank you. Have a nice day. Bye.
Good night, sir.
Good night, sir. Good night, sir.
Good night, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.